Hi everyone, here is the new video of this series. In this video, we are going to discuss some previous year questions of this chapter. The chapter is atomic structure, very important chapter with respect to the physical chemistry. Now, we are going to start with the systematic manner. First, we are going to discuss the weightage. Then, we will discuss syllabus with the help of the mind map. And then, we will solve some previous year questions. I have divided all the questions into the 18 topics. So it means we are going to discuss questions on 18 topics. Clear? Okay. Now, who will get benefit from this video? So I have been discussing this, right, from my first video. Like, who knows the basic, right? Who has NCERT level knowledge? But when it comes to the problem solving, you cannot solve the questions, right? So when you see this kind of video, so you get the idea how to approach for the particular kind of question, how to solve that kind of question. That's why this video is only for those students, right? And who has done coaching somewhere, it means they have the concepts in their mind but unable to apply it when it comes to the questions. Okay, now how to use this video? First, you have to revise your short notes, you have to revise your NCERT completely, you have to write down the important information in terms of formulas and concepts, right? And then you can start doing the practice, you can start solving the previous year questions. From my first video, I have been saying this constantly, like I have discussed enough number of questions so that I will be discussing enough number of questions so that you can get the better clarity about the concepts and all. But you have to solve other questions also. You have to solve, you have to apply the concepts in other PYQs also, right? In order to achieve better result. Now let's discuss the weightage first. So that is around 6%. We can say 1.5, or we can say 2 questions are going to come in some sets. Otherwise, one question at an average. What are the high priority topics over here? Questions are asked from the Bohr's orbit and the spectral line. So that is a part of the Bohr. So we are going to do lots of questions on this part, right? On this part. Okay, now let's discuss the mind map, or let us get the idea ki what are the topics that we have to study, right, before solving the questions. So in the atomic structure, see, we have some experiments, right? To say we have some experiments, cathode ray discharge tube experiment, anode ray experiment and all. So you can read that part from the NCERT. We have the Millikan oil drop experiment, which says that charge on the oil drop, that is the integral multiple onto the charge of electron, right? So question can come from this formula. Then we have Rutherford's model, so question can come from the limitation of Rutherford's model, right? Yeah, what is a Rutherford model? Alpha particle scattering experiment. We have the Thomson's model. Okay, but the most important part is the Bohr's model, because in Bohr's model you should know the theoretical aspect of the Bohr's model, also the numerical aspect of this model. In the Bohr's model, you have formula for the radius of an orbit, velocity of an electron in an orbit, energy of an orbit, time period of revolution, frequency of revolution, right? Then we have the part spectrum. The spectrum is divided into the emission spectrum and absorption spectrum. Now we have to, or you should know the idea about the numerical aspect of the emission spectra in terms of the Rydberg's formula, right? In terms of the Rydberg's formula. So we have the Rydberg formula, how to calculate the number of spectral lines if the electron falls from this higher state to the lower state, right? So how to calculate the spectral lines. So that is the important part. Then dual nature of light holds a very important value, right? So here we have de Broglie hypothesis, Heisenberg uncertainty principle, and the last but not least, that is the quantum mechanical model of an atom. So in the quantum mechanical model of an atom, just get a good idea about the wave function, how to write the electronic configuration, nodes, and quantum numbers, right? So that is the very important part. Then we have a little bit part, just say in dual nature of light, obviously we are considering two behaviors, matter, or we can say particle behavior and the wave behavior. So you should have the idea ki what is the particle nature of light and wave nature of light. So in the particle nature of light, you have this Planck's quantum theory, black body radiation, right? Photoelectric effect. And in the wave nature of light, you have some formulas with respect to the wavelength, frequency, time period, speed, and all. Right. So these topics are very, very simple, and questions are generally come from the formula, right? So if you learn the formula very well, then you can solve most of the question. That's a guarantee, right? So I have divided the whole atomic structure questions into the questions of 18 topics. So we are going to discuss some questions with respect to the particular topic, so that you will get some kind of idea. Okay, so before wasting or before telling you more, right, let us discuss type 1 question. Now the type 1 question, it is completely based on the quantum theory, right? Quantum theory of radiation. So basically in the quantum theory of radiation, we have this thing, energy is directly proportional to frequency, right? Now energy, if you remove the proportionality constant, so this is going to be E is equal to NH nu. Now from the wave nature of light, we know that frequency is equal to C by lambda. So we can also put energy is equal to NHC over lambda. So H is what? H is the Planck's constant. The value is 6.626 into 10 to the power minus 34, right? Minus 34, and that is going to be joule second. Okay, that's it. Now these energy units, right? They are going to be joule per atom. Joule per atom. But now if you want to calculate energy in terms of electron volt per atom, then you can use this formula 1240 lambda in nanometer. So from this formula, you get the energy in electron volt per atom. Okay, electron volt per atom. Now 1 electron volt per atom, that is equal to 96.43 kilojoule per mole. So you can also learn this value, right? Also 1 electron volt, it is equal to 1.6 into 10 to the power minus 19 joules. Okay, so we are going to use this formula in order to solve the question. Clarity. Now let's solve question number 1. The question number 1 says the energy of 1 mole of photons of radiation of frequency this in joule per mole is, right? So you have to calculate the energy of 1 mole of photons. Plus also there is one more thing, that is capital N. This capital N, it is equal to the number of photons. What number of photons? Total number of photons. Okay. So the point is you have to calculate 1 mole of photons, yani n ka value is what? 6.022 into 10 to the power 23. Okay. Frequency 2 into 10 to the power 12 hertz, and you have to calculate this in joule per mole. Joule per mole, not joule per atom, right? So joule per atom में we have n का value 1. n का value 1. ठीक है. So how to solve this question? How to solve this question? So which formula we are going to use? We will use E is equal to NH nu. So n value is 6.022 into 10 to the power 23. H ka value is given, that is 6.626 into 10 to the power minus 34, and frequency is also given, that is equal to 2 into 10 to the power 12. Right, so when you solve this, you get answer equal to 79.8 into 10 to the power 1, which you can write as 798. Okay, so you have to report in nearest teacher, so that is basically that answer is 798. Okay, that's it. Okay, let's do next question. So next question is electromagnetic radiation of wavelength, that is lambda 663 nanometer, is just sufficient to ionize the atom of metal A. Ionize. What is the meaning of ionization? What is the meaning of ionization? Removal of electron, right? Removal of electron from the isolated gaseous atom. So for that we have to provide energy so that electron can be removed from whichever state. Okay? Or generally for the ionization energy, ground state should be there or electron should be removed from their ground state, right? So it is just sufficient to ionize the atom of metal A, right? So the ionization energy of metal A in kilojoule per mole is. So see how to solve this question. So we have E is equal to Hc over lambda, right? E is equal to Hc over lambda. So H value it is given 6.63. Now you need not to take 6.626 because this is a near integer type question. So whatever is given in the question, so you have to use that information. So we can write this as 6.63 into 10 to the power minus 34. C values, speed of light, that is 3 into 10 to the power 8 meter per second. Then we have a lambda, right? Lambda. So lambda value it is given 663. So 663 into 10 to the power minus 9. But that is for per atom, right or wrong? That is for per atom, na? Per atom. So this is joule per atom, but we have to find out what kilojoule per mole. So we have to find out the answer in kilojoule per mole. So energy for 1 mole or per mole, so that is going to be 6.63 into 10 to the power minus 34 into 3 into 10 to the power 8 into 6.02 into 10 to the power 23. That is Avogadro's number. Na, particles present in 1 mole. Right or wrong? Right. So we get what? 663 into 10 to the power minus 9. So now we have this thing in joule per mole. Now our task is to convert this into kilojoule per mole. Kilojoule per mole. So how to convert joule into kilojoule? So 1 kilojoule is equal to 10 to the power 3 joule. So 1 joule is equal to 1 upon 10 to the power 3 kilojoule. So I am going to divide, right, this by 1000, 10 to the power 3. Now when you solve this completely, so what do you get? You get 180.6 kilojoule per mole. So you can write the answer as 181. Right? You can write the answer as 181. Up now the question is ki ma'am we can use this also na 1 by 124 upon lambda nanometer. So basically 1240 na 1240 we can use this formula, right? And then we can convert 1 electron volt per atom into kilojoule per mole. Hannah, we can do this. Yes, you can definitely do this. But the point is that this 1240, na, that is the approximate number. It's not the exact number. So this is the approximate number. So if you solve via this formula, then what do you get? You get the approximate answer. And in integer type question, it is very important to find out the answer in proper decimal. So that you can report that number into the nearest integer. So 180.6, suppose you get 180.4. So you are going to write the answer as 180, na? Right? But answer is 180.6. So 180.6, it is, we are going to round 180.6 as 181. So that's why for the integer type questions, you can use this formula. But if you have multiple choice question, so you can use this formula. Okay, is it clear? Okay, so that's it. So questions are going to come on this topic. We can have some other formulas which I can write as like just say if I want to calculate wave number, the wave number is 1 by lambda. Frequency is also 1 by time period. Right? So we have certain formulas that you should know in this topic. That's it. Now we are moving to the questions of the topic 2. Now the topic 2 is related to the photoelectric effect. In this effect, we have this formula E is equal to work function, which is phi or W plus kinetic energy of electrons. That is actually the total energy which falls onto the metal plate. That work function, this is the energy associated to produce photoelectric effect. and rest energy is converted to the kinetic energy. Right, so E को we can write h nu, work function को we can write h nu naught plus kinetic energy. So this nu should be greater than or equal to nu naught. This is the threshold frequency. Threshold frequency. Okay, and if we talk about lambda, so lambda should be less than or equal to lambda naught. So lambda naught is what? Threshold wavelength. So we have this formula. Now we can also write this formula as hc over lambda upon hc over lambda equal to hc upon lambda naught plus kinetic energy is half MEVE square. Right? So we are going to use this formula, right, in order to solve the question. Now let's do question number 1. So that is assertion reason question. So question says, in the photoelectric effect, the electrons are ejected from the metal surface as soon as the beam of light of frequency greater than the threshold frequency strikes the surface. Yes, this is true. So frequency of the light which falls onto the metal plate, it should be greater than or equal to the threshold frequency. Right, now reason are, when the photon of any energy strikes the metal in the atom, transfer of energy from the photon to electron takes place. When the photon of any energy, not any energy, right? So that photon should have a particular kind of energy, particular amount of energy which is associated with particular frequency or particular wavelength. Then only ejection of electron will happen. So is reason it is false. So what we can write? Assertion is true, but the reason is not correct. So option number 2 is the answer. Okay. Now let's do next question. Given or values of work function for a few metals are given below. Okay, work function. So we know that E is equal to what? Work function plus kinetic energy. Okay. So question says the number of metals which will show photoelectric effect when light of wavelength 400 nanometers falls on it. It means this is the metal plate. So when a light of wavelength 400 nanometer falls on it, so the number of metals which can show photoelectric effect. And what is photoelectric effect? Ejection of electrons from the metal surface when a light of suitable frequency falls on it. So अब see, here work function it is given in electron volt. Lambda wavelength it is given in nanometers. So what we can do, we can find out this energy with this formula 1240 and lambda nanometer. So when we put value of wavelength over here, so we get answer equal to 3.1 electron volt. It means energy of the radiation which falls onto the metal plate, that is equal to 3.1 electron volt. So question says, well, which can show photoelectric effect, right? So basically that energy should be greater than work function. Na? Energy should be greater than work function. So see, it is 3.1 electron volt. Up now in this case 3.7, 4.8 and 4.3. 3.7, 4.8 and 4.3. Okay, so here energies they are greater than 3.1. So it means lithium, sodium and potassium metals they can show photoelectric effect under this condition. Can show photoelectric effect. So we can say lithium, sodium and potassium work function is less than 3.1 electron volt. So these three metals can show photoelectric effect. So answer is 3. Answer is 3. Okay. Now let's do next question. Question says, what is the work function of the metal if the light of wavelength 4000 angstrom generates photoelectron of velocity 6 into 10 to the power 5 meter per second from it? Okay, and we have to write the answer in terms of electron volt. So how to solve this question? So see, first of all, if we use energy, so energy formula, so that is going to be 1240 upon lambda nanometer. So lambda wavelength, it is given 4000 angstrom. 4000 angstrom. So 1 angstrom, it is equal to 10 to the power minus 10 nanometer. So for this we can write we have lambda equal to 400 nanometer. ठीक है. So total energy associated with this is going to be 1240 upon 400. So we have solved above. So we get that is 3.1 electron volt. Okay, 3.1 electron volt. Up now we have to calculate work function, but first we have to calculate kinetic energy. Why? Because in the formula we have energy equal to the work function plus kinetic energy. Okay, so let's calculate kinetic energy. So kinetic energy is what? Half mv square. So half mass of electron is 9.1 into 10 to the power minus 31, that is in kg, and velocity of electron is given 6 into 10 to the power 5 meter per second. So this is 6 into 10 to the power 5 का whole square. ठीक है. So on solving this you get 162 into 10 to the power minus 7 joules. We have to convert this into electron volt. So we have 1 electron volt is 1.6 into 10 to the power minus 19 joule. So in order to convert this into electron volt, we are going to divide this by 1.6 into 10 to the power minus 19. So that is going to be electron volt. So on solving this, we get kinetic energy equal to 1.01 electron volt. Now, what is the task? We have to put everything in this formula. Energy is 3.1, work function is 1.01, and that is kinetic energy. So the kinetic energy is going to be 3.1 minus 1.01, which is equal to 2.09. Not kinetic energy, that's work function. Let me rewrite. Energy is 3.1, work function we have to calculate. Kinetic energy is equal to 1.01. So work function is 3.1 minus 1.01, which is equal to 2.09 electron volt. Now let's see the option. So in the option we have value equal to 2.1 electron volt. So answer is B. Right? So we can write as 2.1 electron volt. Answer is B. Let's do next question. So next question says the work function of sodium metal is this. That is the work function. 4.41 into 10 to the power minus 19 joule. If photons of wavelength 300 nanometer are incident on the metal, the kinetic energy of the ejected electrons will be. So see, देखो, here we can use two formulas, right? The first work function is how much? 4.41 into 10 to the power minus 19 joule. So I can write this in terms of electron volt. So we can say that is going to be 1.6 into 10 to the power minus 19 electron volt. So on solving this, we get value equal to 2.75 electron volt. Okay. Now let's find out the energy. That is by 1240 lambda nanometer. ठीक है. So we get 1240 upon 300. So that is going to be electron volt, and here we have 4.13 electron volt. 4.13 electron volt. Now we know that energy is equal to work function plus kinetic energy. So let's find out kinetic energy from here. So energy is 4.13, work function is 2.75. So we get 1.38 electron volt. But we have to write the answer in terms of joule. So the next task is to convert electron volt into joule. Okay, bete. So on solving this, we get 2.21 into 10 to the power minus 19 joule, which we can report as 221 into 10 to the power minus 21 joule. We have to report answer with respect to this. Other point is that we have the integer type question and all. So I told you do not use this thing. Although you get the approximate result, but actual answer, it is 222, right? It is 222. So if you use this, kinetic energy is equal to energy minus work function. So energy may, if you use this, hc over lambda minus work function, which is 6. But when you solve this by putting all the values, so here you get 6.63 minus 4.41 and then into 10 to the power minus 19. So you get 2.22 into 10 to the power minus 19, which you can write as 222 into 10 to the power minus 21 joules. So see, if you see, answers are close, but you have to report the answer in terms of that. So my advice is that if you have this kind of question, if the options are not given to you, then what you need to do, you have to use this formula. Do not convert or do not use the formula which is in electron volt. Okay, so here what do we report? So answer is going to be 222. Okay, now let's do the next question. Okay, so next question is based on the graph. So which of the graphs shown below does not represent the relationship between incident light and the electrons ejected from the metal surface? It means we have to use the photoelectric effect equation or photoelectric equation. So first is the kinetic energy of the electrons and energy of the light. So we know that energy is equal to work function plus kinetic energy. So kinetic energy is equal to energy minus work function. Okay, bete. So this is why this is mx plus c. So here intercept is negative. So when we extrapolate this, so we get intercept negative, right? We get intercept negative. So it means this curve is true. Now let's see the second one, B. Kinetic energy of electrons, right? There is no change with the intensity of light. So intensity of light, it is directly proportional to the frequency, right? Sorry. Intensity of light is directly proportional to number of photons. While kinetic energy is directly proportional to the frequency of the incident radiation. So it doesn't change with the intensity of light. So this graph is also true. This graph is also true. So the point is that if you increase the frequency, now if you increase the frequency, then E, we know that what E is equal to work function plus kinetic energy. So we get h nu, this is h nu naught plus kinetic energy. So basically if you increase this frequency, then what happened? Work function is same for that matter. It is not going to change. Its threshold frequency is going to same. So rest of the energy is converted to the kinetic energy of the photoelectrons. So that's why kinetic energy is directly proportional to frequency. The more the frequency of the incident radiation, the more is going to be the kinetic energy. Third one, number of electrons and frequency of light. So see, basically at a particular frequency, photoelectric effect is observed, right? So when the frequency here, it is equal to threshold frequency, then what happens? Injection of electron happens. So number of electrons released or ejected from the metal surface. But the point is that the number of electrons ejected from that, and then what happens? Then it is going to be constant. It means number of electrons, they are going to be constant. The point is that frequency is important to eject the electrons, right? But number of electrons, they are based upon the number of photons of that particular energy absorbed by the metal. If more photons, अगर ज्यादा photons absorb कर रहा है metal, यानी मतलब metal को आप थोड़ा थोड़ा करके ज्यादा एनर्जी दे रहे हो तो ज्यादा इलेक्ट्रॉन्स निकलेंगे. बट आपने एक बार एनर्जी प्रोवाइड कर दी, देन व्हाट हैपेंस? इफ यू प्रोवाइड एनर्जी एट वंस, देन व्हाट हैपन? जितना इलेक्ट्रॉन निकलना होगा उस टाइम निकल जाएगा, फिर नहीं निकलेगा, right? So basically the idea is that if the metal absorbs 1 photon of energy, then it is going to eject 1 electron, right? So this is also true. Last, kinetic energy and frequency of light. So kinetic energy and frequency of light, that is D. So we know that kinetic energy is energy minus work function. So kinetic energy is equal to h nu minus work function. So y is equal to mx plus c. So x is frequency, right? So intercept should be negative now, but here intercept is equal to 0. So it means this is the incorrect curve. This is the incorrect curve. Clear? Incorrect curve. So answer is D. Okay, that's it for the photoelectric. So generally the questions are going to be with respect to the formula. So just get a good hold onto the formula. You can solve all the questions, right? Now we have the type 3 black body radiation. Basically we are going to discuss what is black body. So what is black body? Body which absorbs all type of radiation, right? Which absorbs all radiations of any wavelength and frequency. So we have a curve over here. So this is the intensity versus wavelength curve. So see what happens. We have a body and it absorbs all radiation. ठीक है. Once it emits radiation from itself, so that those radiations are going to be black body radiation. पहले absorb कर लिया, अब क्या कर रहा है, अब अपने अंदर से निकाल रहा है, right? Energy. So it means what happens when it releases energy from itself, from the body, when the energy is emitted from the body, then what happens, energy of this decreases, and if energy of this decreases, so we can say wavelength increases. So that's a plot, that's a basically a plot. So here we get this kind of thing. Suppose this is at T1 at a particular temperature, right? So first wavelength increases, but वो उतना ही, मतलब एक particular एक maximum उस तक हो पाएगा, and then it will decrease. Okay, that's it. Now the question is not directly on the black body, because black body is completely a theoretical concept. So question is based on the quantum nature of the atoms, the figure that is not a direct manifestation of the quantum nature of the atoms. So quantum theory of radiation mein we are going to discuss particle nature of matter, na particle nature. So we have a black body, है ना, and photoelectric effect. So these effects we can only observe if we consider the particle nature of the matter. So that's the idea. So if we see this curve, so that is based on the black body. So it means that curve is true. Intensity of black body radiation. So this is 2. T2 to if on more temperature intensity is more, right? Now second see kinetic energy and frequency. So abhi we have discussed kinetic energy is equal to energy minus work function. So kinetic energy is equal to h nu minus work function. So y is equal to mx plus c. So it means that's the curve for the photoelectric effect. So photoelectric effect we can explain via particle nature. ठीक है. Now third, absorption spectrum increase in wavelength. Absorption spectrum, wavelength increases. See, absorption spectrum, what is absorption spectrum? So what happens ki there is a radiation, right? There matlab we have some radiation, and here we have some sample which absorbs this radiation. So it absorbs some of the radiation and then it emits the other radiation. It absorbs some radiations and then it emits rest of the radiations. So when we split this radiation, then we get the absorption spectrum. Then we get the absorption spectrum. ठीक है, absorption spectrum. So absorption spectrum यहाँ पे दिखा रखा है, spectrum से related curve है, right? Increasing wavelength absorption spectrum. So that is also based on the particle nature of the light, ना? Particle nature में, because substance is going to absorb light in photons, not in the continuous form. So we cannot apply the wave nature over here. We have to apply the particle nature over here. So this is also true curve. Now internal energy of argon with respect to temperature. We know that internal energy is directly proportional to temperature. We have discussed this in thermodynamics, right? So if you increase the temperature, then there is more internal energy. But that is not associated with the particle nature. Is it? No. It is related to what kinetic theory of gases may we can say. Because what happens if you increase the temperature, then some of the energies they are going to increase, and summation of total energy present in the system is equal to the internal energy of the system, right? So that is not the direct manifestation of quantum nature of matter atoms. So option 4 is going to be the false, or that is our correct answer, right? So that is going to be the correct answer. Clear? Okay. So we are moving on to the fourth topic, in which we are going to discuss question based on the radius of Bohr's nth orbit. So how to apply this concept? So basically we have this formula. Radius of nth orbit, it is equal to 0.529 529 into n square over z, and that is in angstrom, where n is equal to number of orbit, and z is equal to atomic number. Z is equal to atomic number. Ab now Bohr's model is applicable for hydrogen and hydrogen-like species. It means it is applicable for single electron species. Okay, bete. Acha. We can use this formula directly, but if we want to do the comparison, then what we can say is, suppose we have to compare R1 and R3, है ना, and Z का value is equal to 1. If I am writing R3, it means N का value is 3. If I am writing R का value 1, तो it means मतलब R1 तो N का value is 1. Okay बेटे, so it means we can write 0.529 into 1 square upon Z, and here we can write 0.529 into 3 square over Z. So if you do the comparison, because Z का value is 1 na, so you can cancel out, so you get ratio equal to 1:9, right? Are you getting this point? So whenever it comes to the comparison, so there is no need to solve everything, you can just relate it like this. Clarity? Okay, then we have the curves. On the basis of that, you have to plot with respect to radius and frequency and all, so you can easily plot, you have the idea about this. Okay, one thing I would like to discuss over here, so radius of Bohr's first orbit of hydrogen atom, it is actually equal to 0.529 into 1 square upon 1, which is 0.529 angstrom, and this is known as A naught. Okay, so what is A naught? So this is the radius of Bohr's first orbit of the hydrogen. Now let's do the first question. Assume that the radius of the first Bohr orbit of hydrogen is 0.6 angstrom. So radius of the first Bohr orbit of hydrogen atom, it means Z value is 1, N value is 1, which is equal to 0.529 into N square over Z. So 0.529 into 1 square upon 1, 0.529. That is in angstrom, and you have to take this as 0.6. Okay, fine. So this is 0.6. Now we have to find out radius of the third Bohr orbit of helium plus. Third Bohr orbit of helium plus. So N value is 3 and Z value is 2. Atomic number of helium is 2. So we can write 0.529 into N square over Z, or we can say N square upon Z into A naught. Right, so N square upon Z into A naught, so N is 3 square, Z is 2, and A naught value is 0.6. So on solving this further, so we get 3 square into 0.3. So 3 3s are 9 into 0.3. So 9 3s are 27, 2.7 angstrom. Okay, but we have to report our answer in picometers. So 1 angstrom is equal to 10 to the power minus 10 meter, and 1 picometer is equal to 10 to the power minus 12 meter. So we can write 2.7 into 10 to the power minus 10, or for this we can write 270 into 10 to the power minus 12 picometer. Okay, so answer is 270. Okay, that's it. Now let's do the next question. So next question, the radius of the second orbit of Li2 plus is x. Okay, so the radius of second orbit of Li2 plus, it is x. N value is 2 and Z value is 3, which is 0.529 into 2 square upon 3. Right? So we can say x is equal to 0.529 into 4 upon 3. Now we have to find out the radius of the third Bohr orbit or third orbit of Be3 plus. So Be3 plus single electron species. So formula is valid for single electron species. So from here we can find out the value of 0.529. See here 0.529, which is equal to 3x upon 4, which is equal to 3x upon 4. Now let's solve for radius of the third orbit of Be3 plus, where N is 3 and Z is equal to 4, which is 0.529 into 3 square upon 4. 0.529 we can write as 3x upon 4. So 3x upon 4 into 3 square upon 4, which is equal to 27x upon 60. So do we have this in option? Yes, we have. So answer is 3. Answer is 3. Similarly, let's do next question. The radius of the second Bohr orbit in terms of Bohr's radius A naught. So we know that A naught value is 0.529 angstrom, 0.529, right? So we have to find out radius of the second Bohr orbit of Li2 plus. So n value is 2 beta, z value is 3. So 0.529 into n square upon z. So 0.529 we can write A naught, n square is 2 square upon 3. So that is equal to 4 by 3 A naught. So answer is option number 3. Okay. Now let's do next question. Next question says the difference between the radii of third and fourth orbits of Li2 plus is delta R1. What is delta R1? Difference in the radii of the third and Bohr orbit. Third and Bohr orbit. So what do we write? 0.529 common and z is also common. And here we can write 3 square minus 4 square. Why? Because here R3 में n value is 3 and in R4 n value is 4 beta. So 3 square minus 4 square, right? Up now we have to find out the ratio. So delta R2 is going to be delta R2, it is going to be R3 minus R4. So again, either I can write Z1 because here we have Li2 plus and here I can write helium plus. So Z value is different. So 0.529 upon Z2 and we can write what? 3 threes are basically 3 square minus 4 square. So when we find out the ratio, if we want to find out the ratio, so ratio is going to be, see, delta R1 is to delta R2. So 0.529 upon Z1 and this is 3 square minus 4 square and here we can write 0.529 upon Z2 3 square minus 4 square. So cancel, 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 cancel. So ratio is 1 by Z1 is to 1 by Z2. So what is Z1? Z1 is the atomic number of lithium 3 and Z2 is the atomic number of helium, right? So it means we can write 1 by 3 is to 1 by 2. So 2 is to 3 is going to be the answer. 2 is to 3 is going to be the answer. The answer is option number 3. Okay. Okay. Now that's it. So we have right 2 is to 3, right. Now we are moving to the next topic, velocity of Bohr's nth orbit. So how to find out velocity of Bohr's nth orbit? By this formula, 2.18 into 10 to the power 6 into z by n meter per second. Question can come to find out the ratio like v1 is to v2. So what you need to know, z1 upon n1 is to z2 upon n2 because 2.18 into 10 to the power 6 is constant. If z1 is equal to z2, so we can say 1 by n1 is to 1 by n2. So in that way you can find out the ratio of the velocity of the Bohr's orbit. Okay. Now let's do the question on this. If an electron is moving in the nth orbit of hydrogen atom, then its velocity of Vn for nth orbit. It's very simple question, right? Velocity, it is directly proportional to z over n. Na? So obviously answer B is going to be the correct answer. Okay, is it clear? Now let's move to the next type of question or next topic, that is the energy of Bohr's nth orbit. A very important topic, and we are going to discuss some questions on this topic. It's very important topics. So let me write down some important formulas which we are going to use over here. So what is the formula for total energy of the nth orbit? So first of all, total energy is actually equal to kinetic energy plus potential energy, right? Okay, so total energy final formula is minus 13.6 into z square upon n square electron volt per atom. If we need this energy in joules, so that is going to be 2.18 into 10 to the power minus 18 into z square upon n square, that is the joule per atom. Okay. Now in the question, kinetic energy, it can be the question like calculate kinetic energy or calculate potential energy. So kinetic energy, how to find out kinetic energy? So kinetic energy is basically minus of total energy, and potential energy is what? That is equal to 2 times of total energy. Okay. Up now, if we are saying ki this is N1 is one state and N2 is the three state. So you have to find out the energy which is required to excite this electron from first state to third state. So it means you have to find out difference in energy. So for that you can use this formula delta E, that is equal to 13.6 into Z square, and then 1 by N1 square minus 1 by N2 square, where N1 is going to be the lower state, not initial state. N2 is going to be the higher state, not final state. Understood? N1 is lower state while N2 is the higher state, not initial and final state. Okay, they are not initial and final states. Okay, clear? Now next formula, if there is a question calculate ionization energy, so ionization energy is generally E infinity minus E1. E infinity is always 0, so minus E1. So the formula is plus 13.6 into Z square. That is electron volt per atom. Now we can have the question on binding energy, that is going to be E infinity minus En. What is binding energy basically? This is the energy required to remove the electron from any state, not from the ground state, from any state, right? So here we can say this is going to be what? That is going to be 13.6 into Z square upon N square. Okay, that is also in electron volt per atom. Now let's start solving the question. So the question number 1 says the electron in nth orbit of Li2 plus. Nth orbit of Li2 plus. So if Li2 plus is there, so atomic number is what? Hydrogen, helium, lithium. So atomic number is 3. Is excited to n plus 1 state. So electron kya hai? It is in this level and it is excited to n plus 1 level. Okay. Using the radiation of energy what? 1.47. It means delta E is given 1.47 into 10 to the power minus 17 joule. Okay. And we have to find out the value of N. We have to find out the value of N. And RH value is also given 2.18 into 10 to the power minus 18 joule. So see, we are going to use this formula delta E is equal to what? 2.18 into 10 to the power minus 18 Z square, and that is 1 by N1 square minus 1 by N2 square. So N1 is the lower state. So here lower state is equal to N1 and N2 is the higher state, and here N2 is actually equal to N plus 1. Clear? So here I am not taking N or N plus 1, I am taking N1 and N2 only. So delta E is how much? 1.47 into 10 to the power minus 17, which is equal to 2.18 into 10 to the power minus 18. Z square is what? 3 square. And here we can write 1 by N1 square minus 1 by N2 square. Okay, so on solving this further, what do we get? We get 1 by N1 square minus 1 by N2 square is equal to 1.47 into 10 to the power minus 17 divided by 2.18 into 10 to the power minus 18 into 9. ठीक है? Into 9. So when you solve this further, you get value equal to basically 1 by N1 square minus 1 by N2 square. So you get value equal to 0.75. So 0.75 can be written as 75 upon 100. So 75 upon 100 means 3 by 4. 3 by 4, it means this is 3 by 4. 1 by N1 square minus 1 by N2 square, that is equal to 3 by 4. Now how to solve this? So if I say N1 is equal to 1 and N2 is equal to 2. So what happened? 1 by 1 square minus 1 by 2 square, which is 1 by 1 minus 1 by 4, which is equal to 3 by 4. Right? So it means we can say that the value of N is equal to 1 and value of N plus 1 is equal to 2. Right? So here answer is 1. Answer is 1 over here. Clear? Okay. Now let's do the next question. Next question says the energy of an electron in the first orbit of the hydrogen atom is this. So energy of electron in the first orbit, yani n is equal to 1, and hydrogen atom, so hydrogen atom Z is equal to 1. So that is equal to minus 2.18 into 10 to the power minus 18 Z square upon n square, which is 1, 1. So E1 is 2.18 into 10 to the power minus 18. Now its energy in the third Bohr orbit. So we have to find out the energy in third Bohr orbit. N is equal to 3, which is minus 2.18 into 10 to the power minus 18. Then Z ka value is 1 only, and this is 3 is equal to this. So this can be written as E1. So we can say E1 upon 9. So question says 1 by 9th of the value, 1 by 27th of this value, 3 times of this value. So what is the answer? Obviously 1 by 9th of the value is the answer. Simple question, right? Now let's do next question. Next question says, bete, the ground state energy of hydrogen atom is this. Ground state means N is equal to 1. Hydrogen atom means Z is equal to 1. Energy is minus 13.6, yani E1 it is equal to minus 13.6, that is in electron volt. Badhiya. Now the energy of second excited state. So second excited state is equal to N is equal to 3. Okay, why N is equal to 3? For a second, देखो. Ground state is 1. So when electron goes from 1 to 2, so that is going to be the first excited state, right? And when electron goes from 1 to 3, then that becomes second excited state. Okay, so second excited state is third excited state is N is equal to 4, fourth excited state is equal to fifth one, right? So here helium plus means Z ka value is 2 in electron volt. So how to solve this? E2 is equal to, E3 is equal to, for helium plus, that is equal to minus 13.6 into Z square upon N square, right? Electron volt per atom. So we have to put the values. Minus 13.6, Z square is 2 square upon 3 square. Electron volt per atom. So we can say minus 13.6 into 4 upon 9. So on solving this further, you get minus 6.04 electron. Okay. So what is the answer over here? Answer C, right? Correct option is option number C. Now let's do next question. Okay. According to Bohr's atomic theory, kinetic energy of electron is Z directly proportional to Z square upon N square. See, we have already discussed what kinetic energy is equal to minus of total energy, and minus of total energy is minus 13.6 upon Z square upon N square. So we can say that kinetic energy is directly proportional to Z square upon N square. Very good. So this statement is true. Okay. Now, the product of velocity of electron and principal quantum number Vn is Z square. So velocity of electron and principal quantum number. So for B option, velocity of electron in nth orbit is 2.18 into 10 to the power 6 into Z over n. That is in meter per second. That is in meter per second. Okay, bete. B option के लिए velocity is equal to 2.18 into 10 to the power 6 into Z upon n meter per second. Okay. So velocity into n is equal to 2.18 into 10 to the power 6 into Z. So Vn is directly proportional to Z, not Z square. So it means this statement is false. Clear? Okay. Now next, frequency of revolution of electron in an orbit is Z cube and Z cube upon N cube. It is given. So let's check how to check frequency. So see, frequency is basically 1 by time period, and we can write speed is equal to distance over time. Distance over time. So time can be distance over speed. So we can write distance over here, speed over here. So speed is 2.18 into 10 to the power 6 into Z over n, and distance is 2 pi r circumference, because this is the frequency of revolution. So for the revolution, distance is going to be the circumference, right? So here we are going to put the value of r. So Z by n, and what is radius? 0.529 into n square by z. So although into 10 to the power minus 10 karna hai, but there is no need because we have to find out the proportionality, right? So here we can say frequency is directly proportional towards z square upon n cube. Z square upon n cube. But here it is given z cube upon n cube. So this is false. This is false. Okay. Now last one is Coulombic force of attraction on the electron is z cube upon n4. Coulombic force. So beta, Coulombic force is D, that is K Q1 Q2 upon R square. That is a Coulombic force. What you need to do? You अब यहाँ पे if that is for any hydrogen like species or hydrogen, so we are going to replace this with KZE square over R square. In place of R, what we can write? In place of R, what we can write? We can write 0.529 into n square upon z का square, right? N square upon z का square. So on solving this further, you get what? Z cube upon n4, है ना? Directly proportional to z cube upon n4. So if it is directly proportional to z cube upon n4, so this is true. This is true. Okay. So correct options, they are going to be A and D. So option 2 is the correct answer. Okay. Is it clear? Okay. Now we are moving to the next type. So we have some questions related to spectral lines. So in the spectral lines, what do we have? We have emission spectral lines. What bete? Emission spectral lines. ठीक है, of hydrogen atom. So how to calculate total number of spectral lines? Total number of spectral lines, it can be calculated as, एक मिनट बेटे, just give me a moment. Okay, wait, yeah, okay. So total number of spectral lines, they can be calculated as delta n plus 1 divided by 2. So here that is n2 minus n1 and here n2 minus n1 plus 1 divided by 2. Ab n2 is going to be the higher state because emission lines are observed when the electron falls from higher state to the lower state, and n1 is going to be the lower state, right? Ab now we can have different spectral lines, right? We can have different spectral lines. So different spectral lines like different spectral lines Lyman, okay, Balmer, Passion, Brackett, Puffund and Humphrey. So n1 value for Lyman is 1, Balmer is 2, Passion is 3, then 4, then 5 and then 6. n2 value can be 2, 3 and so on, infinity. Balmer 3, 4, infinite, Passion 4, 5, infinite, Brackett 5, 6, infinite, Puffund 6, 7, infinite, Humphrey 7, 8 and infinite. Okay. So basically first line, if we talk about the first line and alpha line. Alpha line for any spectral line, for any series, Lyman series, Balmer series, so that is going to be possess delta E minimum, least minimum energy, right? Minimum होना चाहिए, least. So here जैसे for Lyman 1 n1 is equal to 1 and n2 is going to be 2. But the last line means where delta E is maximum. तो maximum है. So for Lyman, suppose for Lyman n1 is equal to 1 and n2 is equal to infinite. अब now delta E minimum means frequency minimum, and frequency minimum means lambda maximum. Delta E maximum means frequency maximum and frequency maximum means lambda minimum, wavelength minimum. So question can be asked on this thing. So it should be clear कि how to calculate first line, second line, third line, fourth line. जैसे for second line, if I want to calculate second line for Balmer, so first line is this 2 to 3 or 3 to 2 is the first line and 4 to 2 is going to be the second line. Understood? Emission है, so higher to lower. It is going to be higher to lower. अब now, जैसे for example, if we have this one, कि टोटल स्पेक्ट्रल लाइंस यही है बट द क्वेश्चन सेज कि नहीं नाउ कैलकुलेट टोटल नंबर ऑफ लाइमन लाइंस और टोटल नंबर ऑफ लाइमन लाइंस not Lyman lines, total number of spectral lines which falls in UV region. So how to calculate? So Lyman means n minus 1. Balmer, how to calculate these kind of line? N minus 2. Lyman, Balmer, Paschen, bracket, Puffend, and then Humphrey. Here Paschen n minus 3, bracket n minus 4, Puffend n minus 5, and Humphrey lines n minus 6. Okay, so Lyman lines falls into UV region, Balmer lines visible region, and all other lines they fall in infrared region. Understood or not? So these are some formulas which we are going to use over here. On the basis of that, let's do the question number 1. If wavelength of the first line of the Paschen series of hydrogen atom is 720 nanometer, then the wavelength of the second line of the series is in nanometer. So see, for Paschen line, right? For Paschen line, first line is going to be Lyman Balmer Paschen. So N1 is equal to 3. And first line के लिए N2 value should be 4. Right? N2 value should be 4. So here lambda 1 is given, that is 720 nanometer. Now we have to find out the wavelength for the second line of this. Second line. So second line is N1 value is 3 and N2 value is 5. Okay, so we have to find out lambda 2. Clear? So see, 1 by lambda 2 is equal to RHZ square upon 1 by N1 square minus 1 by N2 square. Clear? So Z is actually equal to 1 because this is hydrogen atom. So we can say 1 by lambda 2 is equal to RH into 1 square upon 1 by 3 square minus 1 by 5 square. Right? 5 square. Now RH ka value we are going to find out from the first one. From the first one we are going to find out the RH ka value. How? So let's do it. So 1 by lambda 1 it is equal to RH into 1 square upon 1 by 3 square minus 1 by 4 square. Okay. So we can write 1 by lambda 1 is equal to RH upon 1 by 9 upon 16. Okay. So 1 by lambda 1 is equal to RH, or we can say 9 into 16, or we can say 16 minus 9. So 16 minus 9, it is going to be 7, right? Clear? So 1 by lambda 1, it is equal to RH into 7 upon 9 into 16. Clear? Now RH value from this, from equation number 1, right? RH value from 1. RH from 1. So that is going to be 9 into 16 upon 7 into lambda 1. So lambda 1 value is 720. So 9 into 16 upon 7 into 720. Okay. Now this is equation number 2. So we are going to put equation number or RH value of this into 2. So putting the value of RH in equation 2. So we get 1 by lambda 2, RH is 9 into 16 upon 7 into 720, and then 1 by 9 minus 1 by 25. Okay, 1 by 9 then 25. So we can say that 1 by lambda 2 is equal to 9 into 716 upon 7 into 720. So 9 into 25, and here we write 25 minus 9. ठीक है? Clear? So we get 1 by lambda 2 is equal to 9 into 16 upon 7 into 720 into 9 into 25. So 9 cancel out, right? And we can find out the lambda 2 value from here. So lambda 2 value, it comes out to be 492.18 nanometer. So we have to report answer as 492. We have to report answer as 492. Okay, so answer is 492. Clear? Now let's do the next question. So next question, the shortest wavelength of hydrogen atom in Lyman series is lambda. Shortest wavelength. Shortest wavelength means maximum frequency, and maximum frequency means maximum energy. So maximum energy, for a maximum energy for Lyman series, right? N1 value is 1 and N2 value is infinity and wavelength is lambda. So question says the longest wavelength in Balmer series of He plus is. ठीक है. So see, we can say 1 by lambda is equal to RH into 1 square upon 1 by 1 square minus 1 by infinity square. Okay bete, so this is 1 by lambda, that is RH. Okay, this is first equation. Now second, the longest wavelength in Balmer series. So longest wavelength means minimum frequency. Minimum frequency means minimum energy. Minimum energy for Balmer 1, that is N1 is equal to 1 and N2 is equal to 2. Sorry, not N1 is equal to 1. That is N1 is equal to 2 for Balmer 1, right? N1 is equal to 2 and N2 is equal to 3. That is for the Balmer 1, right? So for this emission line, least energy is emitted. Okay, so we write 1 by lambda 2 is equal to RH Z square, because this is for helium plus, so Z ka value is 2 for helium plus, so 2 square upon 1 by 2 square minus 1 by 3 square. Now we are going to put RH value as 1 by lambda. So 1 by lambda 2 is equal to 1 by lambda. Okay, 1 by lambda 2 is equal to 1 by lambda into 4 and then 1 by 4 minus 1 by 9. Okay, so 1 by lambda 2 is equal to 4 upon lambda, and this is 36, and then this 9 minus 4. Okay, 9 minus 4, that is going to be 5. Okay, bete. So we can say that, what we can say that lambda 2 is equal to 36 lambda upon 4 into 5. So this is going to be 9 lambda by 5. This is going to be 9 lambda by 5. So that's the value for the longest wavelength in Balmer series of He plus. So 9 lambda by 5. So it means answer 2 is the correct answer. Okay. Now let's do next question. Next question says, which transition in the hydrogen spectrum would have the same wavelength as the Balmer type transition from n is equal to 4 to n is equal to 2 of He plus spectrum? So what transition in hydrogen spectrum would have the same wavelength as the Balmer, so hydrogen and He plus? So okay, same wavelength as the Balmer type transition from n is equal to 4 to n is equal to 2. So here n1 is equal to 2 and n2 is equal to 4, because n1 is the lower state and n2 is the higher state, and z ka value it is 2. So what we can say? We can say that same wavelength hai. So same wavelength means lambda wavelength 1 by lambda of hydrogen is equal to 1 by lambda of He plus. Right, so we are going to equate this. So this is going to be RH into 1 square Z square upon 1 by N1 square minus 1 by N2 square, which is equal to RH into 2 square upon, not upon, in bracket 1 by 2 square minus 1 by 4 square. Okay, so RH cancel out, RH cancel out, and we get 1 by N1 square minus 1 by N2 square, which is 4. And here we can write 1 by 4 minus 1 by 16. So let's take 4 inside the bracket. So by doing so, we get 1 by n1 square minus 1 by n2 square, and we get what? 1 minus 1 by 4, which we can write as 3 by 4. Now we have to select from the option, right? We have to select from the option. So basically answer is this, n1 is equal to 1 and 2, because if 1 by 1 square minus 1 by 2 square, so that is 1 minus 1 by 4 na. So that is going to, that will give us the same result, right? So answer is this. Okay, now let's do next question. So next question says the number of following statements which is our correct is. So line spectra are used to study electronic structure. Yes, electronic structure means electrons are present in which orbital and all, in which shell. So yes, true. Electronic configuration, basically electron distribution in shell. So this is true. The emission spectrum of atoms in the gas phase show a continuous trend. Emission means not continuous, right? So in the emission spectrum we have some gaps, right? So this is false. An absorption spectrum is like the photographic negative. This is true. This is true. And the element helium was discovered in the sun by spectroscopy method. This is also true, right? This is also true. So basically we have three incorrect option. That is going to be option number 2. A number of following statements which are incorrect, that is going to be 1. Okay, now let's do next question. Given below are two statements. Bohr's theory accounts for the stability and line spectrum of Li plus ion. Accounts for the stability and line spectrum. Basically stability nahi. Bohr's theory could not explain the stability and line spectrum of Li plus. See, Li plus lithium. Lithium is 3 and Li plus means 2. So Bohr's model is not applicable for 2 electron species, 3 electron, right? Bohr's model is only applicable for single electron species. So we can say that is going to be the false. Now next, Bohr's theory was unable to explain the splitting of light in the presence of magnetism. This is true. This is the one of the disadvantage of the Bohr's theory or Bohr's atomic structure, right? So that is the disadvantage. So we can say that statement 1 is false, but statement 2 is true, right? Statement 1 is false, but statement 2 is true. So option 2 is the correct answer. Now let's do next question. Difference in wavelength of two extreme lines of Lyman series in emission spectrum of helium plus would be. Helium plus means Z value we have to take as 2. Lyman series, we have to take N1 ka value as 1. Now two extreme lines. Two extreme lines means alpha line, it means first line, and second line. Sorry, not second line, last line, right? So for first line we have N1 ka value 1 and N2 ka value 2. And for last line we have N1 ka value 1 and N2 ka value infinity, right? So difference in wavelength we have to find out. So suppose for first line I am taking lambda 1 and for last line I am taking lambda 2. So let's find out 1 by lambda 1. So 1 by lambda 1 is RH into 2 square upon 1 by 1 square minus 1 by 2 square, right? So 1 by lambda 1, it is equal to RH into 4 and we get 3 by 4. 3 by 4, so we get 1 by lambda 1 is equal to 3 RH and lambda 1 value is 1 by 3 RH. Okay. Now similarly we can find lambda 2. So 1 by lambda 2 is equal to RH into 4 because Z square, so 2 square, and we can write 1 by 1 square minus 1 by infinity square, right? So we can say 1 by lambda 2 is equal to 4 RH, or what we can write, lambda 2 is equal to 1 by 4 RH. Now we have to find out the difference. So lambda 1 minus lambda 2, 1 by 4 RH minus 1 by 3 RH. So we get equal to, basically if you want to solve, lambda 1 is what, 1 by 3 RH, sorry, and lambda 2 is this, so 1 by 3 RH minus 1 by 4 RH, so that is going to be 4 minus 3, so 1 by 12 RH, 1 by 12 RH. Clear? That's it. So answer is going to be option number A. Clear? Simple questions, completely based on formula. Let's do next question. If the shortest wavelength of Lyman series of hydrogen atom is X, then the wavelength of the first line of Balmer series of hydrogen atom will be. So what you need to do, shortest wavelength means maximum energy, and maximum energy for hydrogen atom you have to take Z value as 1, N1 ka value 1 and N2 ka value infinity, right? And then wavelength it is given, so lambda 1 it is given, that is x. Up now you have to find out the wavelength of the first line of Balmer series of hydrogen atom. So Z का value is 2, Balmer series N1 2 and N2 is equal to 3, right? So that is going to be this thing, right? And then we have to apply the formula, you have to compare this. So after solving, what do you get? You get option number B as the correct answer. Okay, just try this at home. Now let's do next question. In a sample of hydrogen atom makes transition from fifth excited state. Fifth excited state means N ka value is 6, or we can say N2 ka value is 6. To ground state means N1 value is 1, producing all types of photons. Then the number of lines in the infrared region are. So in the infrared, we have Lyman lines, we have Balmer, we have Paschen, we have bracket, Puffered, and Humphrey. Okay, so Lyman line falls in UV, Balmer visible, and rest all they fall in IR region. So here how to calculate? देखो here n minus 1 total lines, here n minus 2, Paschen n minus 3, bracket n minus 4, Puffered n minus 5, Humphrey n minus 6. It's just now we have to put the values. So here we get 6 minus 3, that is equal to 3, 6 minus 4, 2, 6 minus 5, 1, and here 6 minus 6, that is equal to 0. So if you count total, to 3, 4, 5 and 6. So answer is going to be 6. Clear? Easy question. Let's do next question. Suppose that the hypothetical atom gives a red, green, blue and violet line spectrum. Which jump according to the figure would give off the red spectral line? So see, if we talk about red now in Vibgyor, so red one is going to have least energy, while the violet one is going to have maximum energy. Okay, so least energy means obviously for that line, least energy is emitted. So we have to find that line. So see, here 2 to 1 1 jump, 2 to 1 1 jump, here 4 to 1, so we can say 3 jump, 3 to 2 2 1 jump, and 3 to 1 2 jumps. So now we have options 2 to 1 and 3 to 2. So we know that when you move away from the nucleus, so the shells are getting closer to each other, right? So energy difference also decreases when you move away from the nucleus. So it means answer is going to be 3 to 2, not 1, not 2 to 1. Right, so you can relate in that way. Otherwise you have the formula, right? You have the formula, you can find out del I by using this formula. ठीक है? So that's it. If you want to calculate numerical value, then you can use this formula. Otherwise there is no need to use this value. Use this formula. Okay, now let's do next question. Question says the shortest wavelength of hydrogen atom in the Lyman series is the longest wavelength in the Balmer series is. Same type of question, right? Same type of question. So you have to do question number, the answer is 3, you have to do on your own. Okay, so shortest wavelength means highest energy. So here n1 ka value is 1 and n2 ka value is infinity and z ka value is 1. For this one, z ka value is 2. Longest wavelength means minimum energy. So n1 ka value 2 and n2 ka value 3. So same, right? So just do on your own. Next question. The ratio of the shortest wavelength of two spectral lines of hydrogen atom is found to be about 9. Shortest wavelength, shortest, right? Shortest means highest energy, highest energy. So it means N2 is going to be infinity only. Okay. So spectral line series are, so wavelength, so lambda 1, so it is going to be RH Z square n1 square. Why? Because n2 is going to be infinity and 1 by infinity is equal to 0, right? We have this now, RH Z square 1 by n1 square minus 1 by n2 square. So n2 is going to be infinity, so RH Z square is equal to 1 by n1 square minus 1 by infinity. So this is 0, so that is 1 by lambda 1. Okay, so we can say that 1 by lambda 1 is this. Okay, then 1 by lambda 2 is another one. So what we can say that, we can say that ki bhai lambda 2 by lambda 1, if I want to find out, so that is going to be RH z square upon n1 dash square upon RH z square upon n1 square. So z square cancel. So lambda 2 upon lambda 1, it is equal to n1 square upon n1 dash square, and it is equal to 9. It is equal to 9. So it is possible na, when n1 is 3 or n1 dash is equal to 1. So 3 square is equal to 9. So n1 is 3. So n1 is 3 is true for Passion, and n1 value is 1 is true for Lyman. So answer A is the correct answer. Okay, clear? Now let's do next question. So next question, heat treatment of muscular pain involves radiation of wavelength of about 900 nanometer. Which spectral line of hydrogen atom is suitable for this purpose? So we are going to use that thing only. So 1 by 900, 1 by lambda, that is RH into 1 square, and then 1 by n1 square minus 1 by n2 square. RH value is this given 1 into 10 to the power 5. Okay, so we can say that nanometer है, nanometer. So it's just you have to solve this thing, right? So that is nanometer, ठीक है, that is in centimeter ना, हाँ. So what we are going to do, lambda is in 900 nanometer, so this is 9 into 10 to the power 2 into 10 to the power minus 9 meter, and 1 meter is 100 centimeters, so 10 to the power 2 into 10 to the power minus 9 into 10 to the power 2 centimeter, because we have to take everything in one unit. That's why what we can say 9 into 10 to the power minus 5 centimeter is the value of the wavelength. So in place of 900, I am putting 1 by 9 into 10 to the power minus 5. So what we can say, 1 by n1 square minus 1 by n2 square, it is 1 by 9 into 10 to the power of minus 5 into RH. Okay, bete. So on solving this further, we get 1 by n1 square minus 1 by n2 square is equal to 1 upon 9 into 10 to the power minus 5 into 1 into 10 to the power minus 5, right? So 10 to the power, it is 10 to the power 5, not 10 to the power minus 5. So we can say 10 to the power 5, so cancel. So we get 1 by n1 square minus 1 by n2 square is equal to 1 by 9. If it is 1 by 9, so how to solve this, right? So a question says ki for which thing it is going to be true, right? For which one it is going to be true. So for which one it is going to be true? So we can say, if we say passion infinite to 3, we have to do the comparison only. So we can say 1 by 3 square minus 1 by infinite square, it is equal to 1 by 9. Yes, it is true. So 1 by 9 is equal to 1 by 9, right? So basically option 2 is the correct answer. Okay, now let's do next question. So next question says, for the Balmer series in the hydrogen atoms, this the correct statement among 1 to 4 are, as wavelength decreases, the lines in the series converge. So see, if wavelength decreases, so energy increases, and energy, when energy is more, then the shells are getting closer to each other, so that is going to be true. We can say lines in the series also converge. Now the integer n1 is equal to 2. The integer n1 is equal to 2. That is true for Balmer, which is true. सही बात है. This is true. The line of longest wavelength. Longest wavelength means minimum energy. Minimum energy के लिए if n1 is equal to 2, तो n2 should be 3. Yes, this is true. The ionization of hydrogen can be calculated from wave number of those lines. नहीं, ये नहीं. Ionization energy is different, because ionization energy is energy required to electron from the ground state, from the isolated ground state. So we cannot find out the ionization energy with respect to the wave number of this line, right? We have to use the energy formula for that. So here 1, 2, 3, they are going to be the correct answer. So option 2 is the correct answer. Okay, now let's do next question. So for any given series of spectral lines of atomic hydrogen, okay, so maximum minus del minimum be the difference in maximum and minimum frequencies in centimeter inverse. Okay, fine, in centimeter inverse, so the ratio of this. So what we are going to do over here, देखो, we know that delta E is equal to 13.6 Z square upon 1 by N1 square minus 1 by N2 square. Now delta E we can write H nu, so 13.6 Z square upon 1 by N1 square minus 1 by N2 square. So frequency we have to find, so this is going to be 13.6 Z square upon H 1 by N1 square minus 1 by N2 square, है ना? We have to find this thing. अब now how to solve this? So what we are going to do? So first, difference in maximum minimum frequency. So पहले first we are going to find out this Lyman, that is maximum frequency minus minimum frequency. So for maximum frequency, N1 is equal to 1 and N2 is equal to infinite. And for minimum frequency, N1 is equal to 1 while N2 value is equal to 2. Okay, so let's do this. So what do we get? We get 13.6 1 square because hydrogen atom, that is H. So 1 by 1 square minus 1 by infinite square minus 13.6 1 square upon H, then 1 by 1 square minus 1 by 2 square, which we can write as 13.6 upon H minus 13.6 upon H, and that is going to be 3 by 4 बच्चे, यही होगा ना, 3 by 4. That's it. So अब now how to solve this? 13.6 H common, 13.6 upon H common, and we get 1 minus 3 by 4, which we can write as 13.6 upon H, and we get 1 by 4. Okay beta, so that is first. Now we have to find similarly Balmer one, for Balmer one, है ना? We have to find this for Balmer one. So let's find out Balmer one. Maximum and minimum, right? So that maximum and minimum. So maximum one, N1 is equal to 2, N2 is equal to infinite, and minimum N1 is equal to 2, N2 is equal to 3. So we can say 13.6 H and 1 by 2 square minus 1 by infinite square minus 13.6 upon H, that is for hydrogen only. Yeah, that is for hydrogen. So ठीक है, Z square, Z is 1, so I am not writing Z square, right? So here what we can write, 1 by 2 square minus 1 by 3 square bete. So this is going to be 13.6 H into 4 minus 13.6 upon H, 1 by 4 minus 1 by 9. So on solving, 13.6 H into 4 minus 13.6 H, so we get 5 upon 36, right? 5 upon 36. So it's just we have to solve this. So on solving this further, we get 13.6 H, 4H common ले लेते हैं. Let's take 4H common, and we get 1 minus 5 upon 9. So we get 13.6 4H into 4 by 9, to 4 cancel. So we get 13.6 H9. ठीक है, so this is equation number 2. अब now if we compare, मतलब 1:2 करेंगे, if I do 1:2, so if I do 1:2, we get answer equal to 9:4. So 1:2, it gives us 9:4. Clear? So answer is C. Very good. That's it. Now let's do next question. For emission line of atomic hydrogen, N initial is 8, and N final is N. N initial emission है, so Ni is going to be the higher state, है ना? That is going to be higher state, so this is N2. And N final is going to be the lower state, and that is going to be N1. So the plot of wave number against 1 by N square will be. So ठीक है, so we know that wave number is equal to RH Z square upon 1 by N1 square minus 1 by N2 square. So we can say RH Z square 1 by N square minus 1 by 8 square. So for this we can say that wave number is equal to RH Z square 1 by n square minus 1 by 64. Now this is for hydrogen atom, so we can say that RH upon n square minus RH upon 64. Okay, so we have to compare this with y is equal to mx plus c. Y is equal to mx plus c. Okay बेटे, so slope क्या हो जाएगा, तो we get a straight line equation and slope value is equal to RH, right? And then we get the linear with slope RH. That's it, right? Intercept is going to be negative, but we get a linear with slope equal to RH. ठीक है? Intercept is going to be negative. So answer is going to be this. Okay. Okay, now we are moving to the next type of question, which is based on de Broglie wavelength. So de Broglie wavelength or wavelength for matter wave, that is called de Broglie wavelength. So here we are going to consider both particle and wave nature. So we have certain formulas for that, like lambda de Broglie, it is equal to what? H upon momentum, or we can say lambda de Broglie is equal to H upon mv. We can also find out de Broglie wavelength if we have kinetic energy, so 2m kinetic energy. We can find de Broglie wavelength if we have voltage given, so 2m ev. We can find de Broglie wavelength if we have h upon under root 2m qv, मतलब any charge particle के लिए. We can find out de Broglie wavelength with respect to that. We can find de Broglie wavelength of the electron moving in any orbit by this formula, n lambda de Broglie is equal to 2 pi Rn, where Rn is going to be the radius of that orbit in which the electron is revolving, right? Nth orbit. Now we can also have lambda de Broglie like 1 by 2 3 under root voltage. V is voltage, not the velocity. And lambda de Broglie, it comes out in the nanometer. Clear? Okay, so now on the basis of these formulas, these formulas, right? Let's discuss question one by one. The wavelength of an electron of kinetic energy, this is this. Basically, we have to find out the wavelength, right? Mass of electron is given 9 into 10 to the power minus 31 kg, and Planck's constant value, it is also given. So see, lambda de Broglie is equal to h upon under root 2m kinetic energy. We have to use this formula. So h value is 6.6 into 10 to the power minus 34 bete. Now under root 2 into 9 and into 10 to the power minus 31, and kinetic energy is 4.50 into 10 to the power minus 29. ठीक है, so on solving this na, we get 6.6 into 10 to the power minus 34, and on solving this we get 81 into 10 to the power minus 60. So what do we get? We get 6.6 into 10 to the power minus 34 upon 9 into 10 to the power minus 30. So on solving this further, we get 0.73 into 10 to the power minus 4. But we have to report the answer in terms of minus 5. So we can say 7.3 into 10 to the power minus 5. So answer that we have to report is 7. Okay, 7. Clear? Just the formula based question. Okay, now let's do next question. If the radius of the first orbit of hydrogen atom is a naught, okay, then the de Broglie wavelength of electron in third orbit. The third orbit, है ना? The third orbit means n lambda de Broglie is equal to 2 pi Rn, and a naught means 0.5 to 9 is equal to a naught. Why? Because R1 is 0.5 to 9 into 1 square upon 1, n square over z. So 0.5 to 9, and its value is given as n a naught, right? So n lambda de Broglie is 2 pi Rn. So if we have 3 lambda de Broglie, it is 2 pi 0.5 to 9 into 3 square upon 1. So we can say that lambda de Broglie is equal to 2 pi upon 3 into a naught into 3 into 3. So cancel. So we get 6 pi a naught. Okay, lambda de Broglie is equal to 6 pi a naught. So answer is going to be the third one. Okay, now let's do the next question. So next question says, if P is the momentum of the fastest electron ejected from the metal surface after the irradiation of light having wavelength lambda, then for 1.5 momentum of the photoelectron, the wavelength of this light should be. So here now what we are going to do, we are combining de Broglie wavelength with the photoelectric effect. So see this, total energy is equal to work function plus kinetic energy. लिखा है P is the momentum of the fastest electron ejected, fastest, so fastest electron ejected में what we are going to say, E is equal to kinetic energy. ठीक है, total energy जो भी है that is converted to kinetic energy, right? So now we have E is equal to hc over lambda, kinetic energy is half mv square. Now we are going to relate this with momentum because this is say कि P is the momentum of the fastest electron ejected. So what I am going to do, half mv square multiply by m and divide by m. So we get hc over lambda is equal to half m square v square upon m, or we can say hc over lambda is equal to half p square upon m, right? We get this thing. ठीक है. Up now, if I'm going to relate this p square with lambda, so can I write this कि p square is inversely proportional to lambda? P square, not p2, right? So this is p square is inversely proportional to lambda. भाई लिख सकते हैं, बिल्कुल सही. So what we can say that p1 upon p2 का whole square, it is equal to lambda 2 upon lambda 1, right? So if p1 is p, फिर then क्या है? 1.5 p momentum. तो 1.5 यानी 1.5 p square. So lambda 2 we have to find out, and lambda 1 value it is given, that is lambda. So let's do this. So we get what we can write that 15 upon 10 हो जाएगा ना 1.5 को, है ना 1.5 को what we can write that p cancel, so we get 10 upon 15, 2 is equal to lambda upon lambda 1. So 5 2s are 5 3s are, so 2 by 3 square is equal to lambda 2 upon lambda 1. So we can say that lambda 2 is equal to 4 by 9 lambda 1, है ना 4 by 9 lambda 1. So answer is this, option number A. This is going to be the correct answer. Now let's do next question. A proton and a lithium nucleus are accelerated by same potential. Voltage is same. A voltage is same, it means we have to use this formula. H upon under root 2m qv, right? अब now if lambda lithium and lambda p denote the de Broglie wavelengths of this and this, lithium and proton respectively, then the value of lambda lithium upon lambda p is x into 10 to the power minus 1. Just do it. So lambda lithium upon lambda p. So that is going to be h upon under root 2 mass of lithium q of lithium v upon h upon under root 2 mass of proton q of proton v. ठीक है. So let's cancel out and we get under root mass of proton q of proton, then mass of lithium and q of lithium. So mass of lithium is given 8.3 times mass of proton. ठीक है, mass of proton. So how to solve this? So we get बेटे lambda lithium upon lambda p, which is equal to mass of proton q of proton. Mass of lithium is 8.3 times mass of proton and q proton. So Li 3 plus है ना. So it means charge on lithium is going to be 3 times charge on proton. So we can write 3 into qp. So cancel 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 cancel, right? Cancel हो गया ना सारी चीज. So we get 0.2 as the answer. So we can say 2 into 10 to the power minus 1. ठीक है बेटे. So answer is 2. Value of x is equal to 2. Now let's do next question. The de Broglie wavelength associated with the photoelectron. Right now we have derived this kind of equation. So it means total energy, work function plus kinetic energy. So at total energy is h nu, work function is h nu naught, and kinetic energy ko we can write what? P square upon 2m. Okay bete. So what we can say that the question says de Broglie wavelength lambda associated with the photoelectron, right? So we know that lambda de Broglie is equal to h upon p. So p is equal to h upon lambda de Broglie. So we can say that h nu or h nu is equal to h nu naught plus h square upon lambda de Broglie square into 2m. So h cancel out, right? H cancel out. So we get H upon lambda d Broglie 2m lambda d Broglie square is equal to mu minus mu naught. Right, bete? So lambda square d Broglie is equal to h upon 2m mu minus mu naught, and lambda d Broglie is equal to under root h upon 2m mu minus mu naught. So lambda d Broglie is inversely proportional to mu minus mu naught ka power half. Right? So we can say answer is going to be option number D. So option number D is going to be the correct answer. Okay. Now let's do next question. Next question says, when a light of wavelength 248 nanometer falls on a metal of threshold energy 3 electron volt, then the de Broglie wavelength of emitted electron is. So how to solve? See, total energy 1240 upon lambda nanometer. Then we can find out the energy in electron volt. So this is 1240 upon 248. So on solving this, we get 5 electron volt. Threshold energy means work function, it is given 3 electron volt. So kinetic energy is energy minus work function. It means 5 minus 3, which is equal to 2 electron volt. Right. Now we have to find out lambda de Broglie. How? H upon under root 2m kinetic energy, bete. That's it. So electron volt है, तो you have to convert this into joules. So 2 into 1.6 into 10 to the power minus 19 joules. That is already given over here. It just now you have to put all the values, just put all the values and then you can get the answer. Right? So when you solve this, you get lambda de Broglie equal to 0.868 into 10 to the power minus 9, which you can write as 8.68 into 10 to the power minus 10. So we have to report, right? This answer is in angstrom and all. So we can say that answer is going to be 9. Answer is 9. That is in the angstrom. Clear? Is it clear? That's it. Now let's do next question. So de Broglie wavelength of an electron in second orbit of Li2 plus. Second orbit of Li2 plus 2 lambda de Broglie is equal to 2 pi Rn, lithium का है ना, that is for lithium plus. So it means 0.529 into 2 square upon, or let me write down the general formula first. And lambda is equal to 2 pi into 0.529 into n square over z. And n cancel. So lambda comes out to be 2 pi into 0.529 into n over z. So lambda is directly proportional to n over z, because 2 pi into 4.529, that is going to be constant. So it means we have to find out the value for n upon z. So for Li2 plus, n value is 2. So we can say n upon z value is 2 by 3. It means we have to find out 2 by 3. Right? So where 2 by 3, but we have to find out where we get 2 by 3. So here n by z is equal to 6 upon 4. So that is 3 by 2? No. For this one, n by z is equal to 3 by 1? No. For this one, we get 4 by 6. So we get 2 by 3. So this is the answer. For this one, we get 3 by 2. So no. So answer is option number 3. Okay. Answer is option number 3. Now that question is also based on same thing, right? N lambda d Broglie is equal to 2 pi Rn. That's it. So just solve on your own. You get the answer equal to 4. Right? You get the answer equal to 4. Let's discuss some questions on the electronic configuration. Very simple and easy questions to do. Right. So if we talk about the electronic configuration, we know that in first shell we have 1s, then in 2s, 2p, then 3s, 3p, 3d, then 4s, 4p, 4d, 4f, then 5s, 5p, 5d, 5f, then 6s, 6p, 6d, and then 7s and 7p. Now electrons are filled in increasing order of their energy, and how to determine the energy? So that is by n plus L value, right? N plus L value. So L value for S is 0, for P is 1, D is 2, and F is 3. So on the basis of that, first electron goes to 1s. First electron goes to 1s. 1s. then it goes to 2s, then 2p and 3s, then 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p, 7s, and then 5f, 6p, and 7d. So in that way, we are going to fill electron. So in S of any shell, we can fill maximum 2 electrons. In P, we can fill maximum 6 electrons. In S2, in P we can fill maximum 6 electrons. In D we can fill maximum 10 electrons, and in F we can fill maximum 14 electrons, right? So in that way, in a similar way, we can write down the electronic configuration. So let's do some questions on the basis of that. So the first question says the number of s electron present in an ion with 55 protons in its unipositive state. So if 55 protons हैं, right? So unipositive state means that is going to carry one positive charge. So if 55 protons है, तो 55 electrons should be there. But we have one positive charge. Due to the one positive charge, we have only 54 electrons. Clear? Now, how to solve this? So see, if you take help from the noble gas, so we have helium, neon, argon, krypton, xenon, radon. So you should know the atomic number of this. So that is 2, 10, 18, 36, 54, 86. अब xenon है, it means 54 है ना, मतलब 54 electrons. So if we write down the configuration for this one, so helium is 1s2, neon 2s2, 2p6, argon 3s to 3p6. This is 4s to 4p6, and then 5s to 5p6. And this is 6s to 6p6. ठीक है बेटे? So it means last electrons they are in 5s. Okay, 5s to 5p6. So अब see 5s to 5p6. So it's very simple to do. Right, 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, 5s, 5p, 5d, 5f, and then 6s, 6p, 6d, 6f. बेसिकली यहीं तक फिनिश कर दो तो इलेक्ट्रॉन्स कहाँ होंगे? 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, and then 4d, 5p. इतना ही है. ठीक है? We have last electron in 5p. अब now question says number of s electrons. You have to calculate total number of s electrons. So s electrons 1s, 2s, 3s, 4s, 5s. So total 5 orbitals है ना. So total 5 orbitals means total 5 s orbitals means we can have maximum 5 into 2, 10 electrons. Because in one orbital we can have maximum 2 electrons. So answer is going to be 4th. That is the 10th. Okay. Now let's do next question. Maximum number of electrons that can be accommodated in a shell with n is equal to 4. See, if n is equal to 4 है ना, n is equal to 4, it means that is a valence shell. So valence shell. So how to write down this type of configuration? If valence shell है, so we write 4s and 4p. Now we have to write penultimate shell. Penultimate shell, the shell which is before valence shell. So for that we write n minus 1d. Valence shell is nsnp. So here n is equal to 4, so we write 4s 4p. Then we are going to write anti-penultimate shell. Anti-penultimate shell. Achha, now here there is no need to apply this concept because question says maximum number of electrons that can be accommodated in a shell with n is equal to 4. So we know that 2 into n square हो जाएगा ना ये तो. n is the number of orbit, so 2 into 4 square, so that is equal to 32 electrons. So directly we can do this thing. But try to understand this concept also. Like 4s 4p a penultimate shell, and then we have anti-penultimate shell, that is n minus 2f. So in that way we can also write down the condensed electronic configuration. Here we write noble gas, and then we can write this kind of thing in order to find out the outermost shell configuration. Okay. Now let's discuss this thing. Arrange the following orbitals in decreasing order of energy. So energy we are going to find by n plus L value, right? So here n plus L value 3 or 0. So 3 plus 0 3. Here we can say 4 plus 0 4. Then 3 plus 1 3, and then 3 plus 2 5. So least energy is for 3. अब 3 में this is 3s, this is 3p, and this is 4s, and this is 3d, because L का value 2 है तो वो 3d है, right? So least energy is going to be for 3s, A का सबसे कम, then C, after that B, and then D. So decreasing order लिखना है तो we write D, B, C, A. So as per that, option 2 is the correct answer. Okay, is it clear? Now let's do the next question. So next question says, which one of the following set of ion represents a collection of isoelectronic species? So here you have to use the concept of elimination method. If you find any element जिसमें electrons अलग दिख रहा है, where the electrons are not same, then eliminate that, right? So जैसे for example, if you see lithium and sodium, you know that lithium atomic number is 3, sodium is 11, so electrons cannot be same over here, so eliminate this, right? Here you can say calcium है ना, so calcium वाला group 2, beta, मांगे, कार, सेंट्रो, बा, तो बेसिकली सी ना, मैग्नीशियम डिफरेंट होगा, कैल्शियम डिफरेंट होगा, स्ट्रॉन्शियम डिफरेंट होगा, बेरियम डिफरेंट होगा, कैन नॉट बी सेम, ठीक है। नाउ जस्ट चेक थर्ड वन, तो थर्ड वन में इफ यू चेक तो सी सल्फर 18 हो जाएगा यहाँ, रेस्ट सब में सेम है बट इन सल्फर 18, तो नो। नाउ चेक डी, तो पोटेशियम है तो 19 माइनस 1 बिकॉज देयर इज अ प्रेजेंस ऑफ 1 पॉजिटिव चार्ज, तो 18 इलेक्ट्रॉन्स, Cl माइनस 17 प्लस 1 18, CH2 प्लस 20 माइनस 2 18, scandium 3 plus 21 minus 3, that is 18. So answer is 4. Okay, that's it. Now let's do next question. In the sixth period, the orbitals that are filled are, sixth period में कौन सा होगा? Here we are going to use that वाला concept कि valence shell, penultimate shell and anti-penultimate shell. So here NS, NP, penultimate N minus 1D, anti-penultimate N minus 2 F. So sixth period means 6S, 6P, then we can write 5D and then 4F. All are possible, na? Right, all are possible. And if we use N plus L value, so this is going to be 4 plus 3, 7. Here 5 plus 2, 7. 6 plus 0, 6. 6 plus 1, 7. So electrons are filled in 6, matlab the order is 6S, then 4F, then 5D, and then 6P. Option 2 is the correct answer. Clear? 6S, not option 2. 6S, 4F, 5D, 6P. So option 1 is the correct answer. Okay, now let's do next question, bete. Next question says, among the following, the energy of 2s orbital is lowest still. So see, potassium, I am writing all complete configuration. So potassium 19 है. So 1s2, 2s2, 2p6, 3s2, 3p6 and 4s1. Hydrogen 1, so 1s1. Lithium 3, so 1s2, 2s1. Sodium 11, so 1s2, 2s2, 2p6, 3s1. So देखो हाइड्रोजन के लिए 2s is higher state, it is not lower. इधर that is a मतलब in this that is a valence state. Okay, but potassium में देखो 2s है but the electron is present in 4s, so we have more energy difference. While in sodium 2s है and electron is in 3s, so we have less energy difference. So lowest it is going to be in potassium. Lowest it is going to be in potassium. Okay, now that's it. Now we are moving to the next type of questions which are completely based on quantum numbers. So we know that quantum numbers are what? They are the result, right? Or result, or we can say solution of Schrodinger wave equation. Schrodinger wave equation है ना? They are the solution of Schrodinger wave equation. So we have how many quantum numbers? 3, which are the solution, right? So we have principal quantum number. We have principal quantum number is n. Then we have azimuthal quantum number. quantum number, which is L. Then we have magnetic quantum number, ml. And then we have spin quantum number. Spin quantum number is not the solution, but we have, this is ms. So if n ka value, n can only have integral value na, n can be 1 2 and all the 0 nahi ho sakta, not that 0, only 1 se orbit hai, that is the orbit. Then l ka value is going to be 0 to n minus 1. ml ka value is minus l to plus l including 0, and spin quantum number ka value 2, either plus half or minus half, right? If in this orbital we have two electrons, one like this, another one is this, so for this ms ka value is plus half, and for this ms ka value is minus half. Okay, principal quantum number, it tells us about the size or shell, azimuthal, subshell. Each value of azimuthal quantum number indicates subshell, and we have S, P, D and F subshell, right? Magnetic quantum number, it tells us about the orbitals. So like in S we have only one orbital 1, in P we have 3, in D we have 5, and in F we have 7. So in total number of electrons, so in each orbital we can have maximum 2 electrons. So in S we can have 2, here 6, here 10 and here 14, right? So we are going to apply this concept in order to solve the question. So let's do the question number 1. Which of the following set of quantum numbers are valid? So in order to solve this question, how to solve? Basically, if n ka value is n, then l ka value is 0 to n minus 1. ml ka value is minus l to l including 0. So if we see option number A, n ka value is 3. So l ka value is 0 to n minus 1. It means L ka value can be 0, 1 and 2. Right? L ka value, it can be 0, 1 and 2. It cannot be 3. So this is incorrect. So it means we can say this is not valid. This is not valid. Now see option number 2. If n ka value is 3, then L ka value can be 0, 1 and 2. If L ka value is 2 from here, so L ka value is minus 2, minus 1, 0, plus 1, plus 2. So this is possible, and as ka we can have two values, either plus half or minus half, so this is valid. Now check for option number 3. If n ka value is 4, तो L का value is 0, 1, 2, 3. If L का value is 0, so ML का value is 0, and S का value is minus half, so this is also valid. Now check D option. If n का value is 3, L का value is 0, 1, 2, 3, so L का value 3 is correct. अब L का वैल्यू 3 है, मैक्सिमम L का वैल्यू इज 3, सो ML का वैल्यू इज -3, -2, -1, 0, +1, +2, +3. दैट्स फॉर मैक्सिमम 1. बट हियर ML का वैल्यू इट इज गिवन -4. So this cannot be true, so not valid. Okay. If you check option number E, S का वैल्यू 0, not possible, not valid. If you check this one, N का वैल्यू 5, L का वैल्यू 2. ML का value 0, L's का value plus half, so this is going to be valid. So out of all, how many quantum numbers are valid? So answer is going to be 3. 3 are valid. Okay. Now let's do next question. Which of the following orbitals do not exist? So which of the following orbitals do not exist? 4D exist? Yes. 3F? No. Only 3S, 3P, 3D. It can exist. It means if n ka value is 3, so L ka value, it can be 0, 1, 2. 0 for 3S, L ka value 1 for 3P and 2 for 3D. So that's the only possible. 1P does not exist because if n ka value 1, so L ka value is 0. That is for 1S. So 1P does not exist, 3F does not exist. Now 5G exists. So 5G. So if n का value 5, तो L का value 0, 1, 2, 3, 4. So it means this is for 5S, this is for 5P, this is 5D, 5F, 5G. So 5G can exist, but Right now it is not in scenario, it is not in a story, right? So which of the following orbitals do not exist? So option B and C, they are going to be the correct answer. Okay, now let's do the next question. So the number of orbitals associated with the quantum number 5 and ms का value is plus half. Number of orbitals. So 5f का क्या होगा? देखो 5s, 5p, 5d, 5f and 5g. ये possible है ना? Because if n का value is 5, so l का value is 0, 1, 2, 3, 4. 0 to n minus 1. Okay बेटे? ठीक है. So now plus half means in as we have one orbital, so only one electron is going to have plus half. Another electron is going to have minus half. So suppose in p we have 3 orbitals, so only 3 electrons are going to have plus half. ठीक है? Plus half. Now d में 5, तो similarly here we have 1 orbital, here we have 3, here we have 5, here we have 7 and here we have 9. How? Just add 2. 1 plus 2 3, 3 plus 2 5, 5 plus 2 7, 7 plus 2 9. So it means total number of orbitals 3 plus 1 4, 4 plus 5 9, 9 plus 9 18. Right? And 18 plus 7, that is equal to the 25. So option 2 is the correct answer. Okay. Now let's do next question. The number of subshell associated with n is equal to 4 and m is equal to minus 2 quantum number. n is equal to 4 है and l का वैल्यू क्या होगा? 0, 1, 2, 3. Right? That is going to be l का वैल्यू. So question says number of subshell associated with n is equal to 4 and m का वैल्यू minus 2. So m का वैल्यू minus 2 कहाँ हो सकता है? देखो, if l का वैल्यू is 2, then ml can be minus 2, minus 1, 0, plus 1, plus 2. And if l का वैल्यू is 3, then ml का वैल्यू is minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. So in 3 we have minus 2 and in l is equal to 2 we have minus 2. Rest में that is not possible. So number of subshells associated with n is equal to 4 and m का value minus 2. So that is going to be how many number of subshells? तो यहाँ पे 2 हो गया ना, 4s, 4p, 4d, 4f. So 2, 2 and 3. ठीक है, this is for 4s, this is for 4p, this is 4d and this is for 4f. So answer is 2. Okay. Now let's do next question. The number of orbitals with n is equal to 5 and ml का वैल्यू प्लस 2. सेम तरीके से करेंगे. ठीक है, m का वैल्यू 5 and ml का वैल्यू 2. So n का वैल्यू 5, so l का वैल्यू is 0, 1, 2, 3, 4. ml का वैल्यू प्लस 2. So it is possible over here, it is possible over here, even it is possible over here. So total that is 3 orbitals. 3 orbitals. ठीक है, यही तो है ना. जैसे l का वैल्यू 2 है, सो ml का वैल्यू इज minus 2, minus 1, 0, plus 1, plus 2. So that is for 5d. So 5d है, so 5 orbitals है ना total. So 1 का ml का वैल्यू इज minus 2. So answer is this. Okay. Now let's do this. The quantum number of 4 electrons are given below. You have to find energy order. How to find n plus l का value? You have to find out. So when you solve this, this comes out to be 6, this comes out to be 5, this comes out to be 5 and this comes out to be 4. So increasing order 4, then 4, then second, then third and then first. Second का why come? Because n का value is 3. So the lowest value of n is going to have less energy. So on the basis of that, option C is the correct answer. Okay, that's it. Now let's do the next question. Consider the hypothetical situation where the azimuthal quantum number value L takes from 0 to n plus 1. It means if L ka value is 0, or sorry, if n ka value is 1, so L ka value is 0 to n plus 1. 0 to n plus 1 means L ka value 0, 1 and 2. So L का वैल्यू 0 is for 1s, 1 is for 1p and this is for 1p. Right. अब question says 9 is the first alkali matter. So the first alkali matter means electron should be present in 2s. Right. Up now see 1s में we can fill 2 electrons. P में we can fill 6 electrons and D में we can have 10 electrons. After that we are going to fill electron in 2s na, because if n ka value is 2, so L ka value is 0, 1, 2 and 3. So for this is 2s. So when the electron fills into 2s, then that is going to be the first alkali metal. Right or wrong? Yes, that's the right one. So it means, देखो 2 plus 6 plus 10, total 18. So it means 19th one is going to be the first alkali metal, not the that one. अच्छा, number of electrons कितना होगा? जो भी number of electrons होगा, that is going to be the number of atoms. ठीक है, number of atoms. ठीक है. Now 13 as a half filled valence shell. So 13 as a half filled valence shell means कि देखो in 1s we can fill 2 electron. In 1p we can fill 1 2 3 4 5 6. So 6 7 8 हो गया. Now in D 2 3 4 तो 9 6 7 8 हो गया. Then 9 10 11 12 13. Yes, the 13 is going to have 1d5 configuration, so it has half filled. So this is true. Now let's check another one. 8th is the first noble gas. So bhai, noble gas first noble gas is helium and it has 1s completely filled. So here not 8th one, second one is the first noble gas. 6 has a 2p valence shell. 6 has 2p, yani sixth atomic number is going to have 2p. 996 number is going to have 1p. So that is also false. So correct answer is going to be the option number 2, right? Correct answer is going to be option number 2. Okay, that's it. Now we are moving to the next type of question that is based on the angular momentum. Okay, so angular momentum may we have 3 formulas. So first is the orbit angular momentum. So orbit angular momentum, it is L. L is equal to mvr, which is equal to nh over 2 pi. Okay, then we have orbital angular momentum. So orbital angular momentum, how to find out? Under root L plus 1 h over 2 pi. And L का वैल्यू S के लिए 0, P के लिए 1, D के लिए 2 एंड F के लिए 3. ठीक है. L का वैल्यू L का वैल्यू S के लिए 0, P 1, D 2, F 3. Then we have what? Then we have spin angular momentum. So for that we have under root S plus 1 h over 2 pi. Now how to find out total spin? Number of unpaired electrons divided by 2. Right? So in that way we can find out. So questions are generally on this orbit and orbital. Okay? So question is the orbital angular momentum of an electron in 3s. तो orbital है तो L का value is 0 ना for S. So we have is xh over 2 pi. So basically we can write under root L plus 1 h over 2 pi. So it is under root 0 h over 2 pi. So x का value is actually equal to 0. So answer is 0. Okay. So questions will be directly. Okay. Now let's do next question that is based on the magnetic moment. So magnetic moment may how to calculate magnetic moment. So that is mu. And we can say under root n plus 2, and that is going to be the Bohr magneton. That's a unit, right, where n is equal to number of unpaired electrons. N is equal to number of unpaired electrons. Acha, if magnetic moment value comes out to be 1 point something, if it is 2 point something, then we can directly find out number of unpaired electrons. How? If magnetic moment value is 1 point something, the number of unpaired electrons, they are going to be 1. 2 point something, so 2. If we have 7 point something, so that is going to be 7 unpaired electrons. In that way, we are going to solve. Okay. So on the basis of that, let's do first question. So first question says, for a metal ion, the calculated magnetic moment is 4.90. तो metal ion has how many unpaired? देखते ही पता चला 4.90 है ना. So it means number of unpaired electrons 4. You can prove this thing. You can even prove this thing. ठीक है, तो आप चेक भी कर सकते हो कि जैसे फॉर एग्जांपल अगर आपको करना है 4 है तो 4 4 प्लस 2 यानी अंडर रूट एन एन प्लस 2. सो ऑन सॉल्विंग दिस व्हाट डू यू गेट 4 into 6, so under root 24, so under root 24 is going to be 4.89, right? That is going to be 4.89. Clear? Now let's do, अच्छा क्या है इधर, question is this only. ठीक है, okay. Now question says the ground state atomic this 26, the spin only magnetic moment is, so we have to calculate what spin only magnetic moment. So spin only magnetic moment this under root n n plus 2, so 26 है. So configuration 3d6 4s2. So when you fill electrons in 3d6, so 1 2 3 4 5 6, so we have 4 unpaired electrons. So if we have 4 unpaired electrons, so 4 plus 2, it means n ka value is 4. So on solving this further, we get under root 24, which is 4.89 Bohr magneton. But we have to report answer in terms of 10 to the power minus 1. So we can write 48.9 into 10 to the power minus 1, which we can write as 49. So here answer is 49. Okay. Now let's do next question. Spin only magnetic moment with atomic number 25. Same 25 है. So 25 basically manganese है ना. So this is 3d5 and 4s2. So number of unpaired electrons 5. So 5 point something होगा, but here 5.26 है, 5.92 है, तो चेक कर लो. But generally it is greater than 5. 5.92 ऐसे ही होता है, 4.89 and all. ठीक है, तो बस check it. So we get 5 plus 2, that is equal to 5 into 7 under root 35. So we get 5.9. ठीक है बेटे, formula is n plus 2 under root. Okay. Now let's do next question. The highest value of the calculated spin only magnetic moment among all transition metal complex. So when we have maximum number of unpaired electrons, and maximum number of unpaired electron क्या होगा, because configuration में d होगा और s होगा ना, तो d5 होगा तो maximum unpaired है ना, maximum unpaired, तो generally d5 होगा तभी होगा, तो maximum is going to be 5.92. ठीक है, दैट इज गोइंग टू बी. अच्छा इधर एक और चीज हो सकती है, जैसे फॉर एग्जाम्पल इफ यू सी क्रोमियम, क्रोमियम इज 24, सो हेयर वी हैव 3d5 and 4s1 ना, है ना. Chromium 24 electrons you have to fill, so 24 electrons if you have to fill, so that is going to be 1s2 2s2 2p6 3s2 3p6, कितना हो गया, then 4s2 and then 3d4. It should be like this. देखो 10 20 24, but here what we write, we write 3d5 4s1. So if we write 3d5 4s1, so how many unpaired electrons? So we have 6 unpaired electrons. So if we have 6 unpaired electrons, so the maximum is going to be 6.93, not 5.92. ठीक है, so this is true. Okay, now let's move to the next type. So here we are going to calculate nodes. So what are nodes? Node can be a plane, angular plane, or it can be a spherical surface where the probability of finding the electron is zero होगा, right? So we have two types of nodes, two types of nodes, radial nodes and angular nodes. We have radial nodes and angular nodes. So radial nodes n minus l minus 1, angular l, and total n minus l minus 1 plus l. So it is going to be n minus 1 total nodes. That's it. ठीक है. So अच्छा इधर we have ना one more concept कि जैसे for example s है ना s. So s orbital starts from 1s. So it means here we are going to have 0 node. Apply कर लेते हैं radial node. 0 radial node. हाँ, n minus l minus 1, तो n minus 0 minus 1, तो 1 minus 0 minus 1, that is equal to 0. p starts from 2p ना, so 0 node. How? 2 minus 1 minus 1, 0. 3 starts from 3d, so 0 node. How? 3 minus 2 minus 1, 0. F starts from 4f, तो 0 node. How? 4 minus 3 minus 1 equal to 0, right? So that is a very important trick. Okay. Now let's do this question. So question says the wave function psi, it is given, this 2s is given. R is equal to R node, radial node is formed. So thus R node in terms of A node. So देखो what you can do. Psi 2s, psi square 2s is 0. Probability of finding electron is 0. If I am saying psi square is 0, it means psi value is equal to 0. And if psi value is equal to 0, so you are going to put all terms equal to 0. We can say 1 by 2, 2 pi is equal to 0. We can say 1 by A node to the power half is equal to 0. We can say E minus R by 2 A naught is equal to 0. And we can even say 2 minus R upon A naught is equal to 0. है ना? So R को we are going to replace with R naught because that is the position of the node where we can find the node where we cannot find any electron. So देखो, if this is going to be 0, then this value should be infinite because 1 by infinite is 0. So pi cannot be infinite. And it has fixed value 3.14. So this is not true. This is not true. We cannot do this thing. Ab A naught also has finite value, na? A naught value is 0.529. So A naught cannot be infinite. So we cannot write this also. So we cannot write this also. Same this one. So we cannot make it this equal to 0. So what is the thing? This is going to be 0. So we can say 2 minus R naught upon A naught is equal to 0, which is R naught upon A naught is equal to 2, and R naught is 2A naught. So it means at 2A naught distance, we are going to find our first node. So answer is 4. Okay. Now let's do next question. The number of atomic orbitals from the following having 5 radial node is 7s, 7p, 6s, 8p and 8d. It means we have to find key out of all these orbitals which one has 5 radial nodes. So 5 radial node means n minus l minus 1 is equal to 5. ठीक है? So it means n minus l is equal to 6. 5 plus 1, that is equal to 6. Okay bete? Simple. Now we have to find out the n minus l value. So here n minus l value 7 minus 0, 7, not true. 7 minus 1, 6, true. 6 minus 0, 6, true. 8 minus 1, 7, not true. 8 minus 2, 6, true. So out of all the orbitals, the number of atomic orbitals which have these nodes, so total answer is going to be 3. Okay, total answer is going to be 3. Now let's do next question. Orbital having 2 radial as well as 2 angular nodes. So angular nodes equal to L. तो 2 है तो L का value is 2. Radial nodes 2. So radial nodes 2, it means n minus L minus 1 is equal to 2. So here n minus 2 minus 1 is equal to 2. So n का value is what? 2 plus 3, 5. L का value 2 is for d orbital. So it must be 5d orbital. It must be which orbital? 5d orbital. एक मिनट बेटा, हो गया, almost done. It is almost done. So that is going to be 5d. Clear? Now let's do next question. A certain orbital has no angular nodes and 2 radial nodes. So the orbital is no angular nodes, यानी L का value is 0. If L का value is 0, तो it must be S. 2 radial nodes means n minus L minus 1 is equal to 2. So n minus 0 minus 1 is equal to 2. So n का value is 2 plus 1, which is equal to 3. So it must be 3s. So option 2 is the correct answer. Okay. Now let's do next question. A certain orbital has n is equal to 4 and ml का value is minus 3. So number of radial node in this orbital is ml का value minus 3. So if ml का value is minus 3, तो we can say that ना कि l का value 3 हो सकता है ना? l का value 3 हो सकता है. ठीक है. अब n का value 4 है, तो बेसिकली n का value 4 है, so l का value is 0, 1, 2, 3. So in L is equal to 3 value, we can have ML ka value minus 3. So it means L ka value is 3. Okay. So it means N minus L minus 1 we have to calculate. So 4 minus 3 minus 1, 0. So 0. Okay? Clear? So now we are moving to the next slide. So in this we are going to discuss some questions which are related to the Schrodinger wave equation and which are related to the probability density question, radial probability density function, right, and the wave function. So we have some plots with respect to that, and then we are going to find out the notes. Questions are very simple, so let me put some of the information related to the this topic, right? Let's do it. So what is Schrodinger wave equation? That is del square psi del x square plus del square psi del y square plus del square psi del z square plus 8 pi square m upon h square e minus v psi is equal to 0. And what is psi? This is psi and this is the wave function of an electron, right? This is the wave function of an electron and this is the storehouse of the information related to electron. And this we can write as del square psi plus 8 pi square m h square e minus v potential energy, then psi it is equal to 0. Now what to do? So generally the questions are basis on the, or they are completely based on the plots, right? So plots, so we have three types of plot. The first plot is the radial wave function plot, radial wave function, which is psi r or r versus r. Okay, so here we should have the information about radial nodes. So important part, radial nodes. Radial nodes n minus l minus 1. Okay, so what happens? Suppose if I'm going to plot in between r versus r, and that is for s. So it starts from here. It's a wave only, right? So that is the plot of s. So this is the plot of 1s because here node is equal to 0. If I plot for 2s, so it is going to be in 2s we have one node, in 2s we have one node, right? Then how do we plot? The wave is going to be like this, like this. Okay, it is not going to touch. So this point represents node, right? So S ka we are going to start from here, but if we have P, D and F, right? P, D and F, so the wave starts from origin. So R versus R ही है, but for P, D and F, the wave starts from origin. So if node do not have node, we do not have node, so the wave is going to be like this. If we have one node, then the wave is going to be like this. Okay, so this represents one node. Clear? So that is for P, D, F, and the node is equal to 1. Okay, so now second plot is based on radial probability density. Radial probability density. So radial probability density, that is r square r or psi square r versus r. So this means probability of finding an electron at a point. एक पॉइंट पे प्रोबेबिलिटी इलेक्ट्रॉन की मिलने की, दैट इज द रेडियल प्रोबेबिलिटी डेंसिटी बच्चे. नाउ हियर व्हाट हैपेंस, सेम एस का प्लॉट डज नॉट स्टार्ट from origin, but P, D and F plot starts from origin. So same kind of plot, but we do not have any negative wave. So जैसे for example S r square r versus r. So for s का if I am going to draw, so that is this. ठीक है, 1s. Or we can say s having node equal to 0. Now here s having node equal to 2. Suppose it is 2. So we are going to plot like this. This is one node, then second this. Okay, is it clear? Is it clear? Right? So this is not going to touch. This will be parallel to the x-axis. So node 2 for S. Now if we have P, but node is 1. So what we can write like this? One node. This is one node, right? PDF, one node. PDF, node 2, node 2. It means we are going to plot like this. 1, 2, 3. Amplitude of wave decreases 1 and 2. Okay? So that is for PDF having node 2. Clear? Now we have one more plot, that is the radial probability density function RPDF versus R. So it tells us about the probability of finding an electron in a region. And what do you mean by the region? In small portion of shell. Small portion of shell. Okay. So here all plots starts from origin. All plots starts from origin. So if we have node, radial node equal to 1, radial node, we are talking about radial node, we are not talking about angular node. So if node 1 hai, and we have RPDF ko we can also write 4 pi r square psi square r, right, versus r. So node 1 means 1 and then 2. Here amplitude increases. Because in first shell we can have 2 electrons, in second shell we can have 8 electrons, in third one we can have 18. So probability of finding the electron in the shell increases, right? So here amplitude, it is going to increase. If we have node equal to 2, if we have 2 nodes, so the plot is going to be like this. 1, wait, 1, 2. So it means 2 nodes. Clear? Now on the basis of that we have some questions. Let's do question number 1. So question number 1 says the number of correct statements from the following. So for 1s orbital the probability density is maximum at nucleus. Yes, true. Basically for s probability density is maximum at nucleus, because this is the nucleus and 1s is this. This is 1s. Then we have some space and then we are going to form 2s like this. Okay? So in between 1s and 2s we have this is the spherical node, that na this part, that is the spherical node. So this is the radial node that we get, radial node. So if this is 1s, this is 2s, so we have obviously in 2s we have one node. Kaise? N minus L minus 1, 2 minus 0 minus 1 to 1 radial node. Clear? So this is true. Now next, for 2s orbital the probability density first increases to maximum and then decreases sharply to 0. Is it true or not? It is not true. Why it is not true? Because this is 2s orbital na. So generally in s orbital what happens? It is maximum nearer to the nucleus and then it starts to decreases, because then it is going to approach towards radial node, right? So in 2s the probability density first increases to maximum then decreases. नहीं ऐसा नहीं होता था. Generally it is maximum nearer to the nucleus. So that is false statement. Now boundary surface diagram of the orbital encloses a region of 100% probability. No, 100% तो मिलता ही नहीं है ना. It is 90 to 95% probability. So this statement is also false. Boundary surface diagram is this only, right? This kind of thing. Next, p and d orbitals have 1 and 2 angular nodes. तो सही बात है. Angular nodes that is equal to L. So L का value for p is 1, तो angular node is 1. L का value for d is 2, तो angular nodes 2. So this is true. Probability density of p orbital is 0 at the nucleus. Is it true? P orbital. सही बात है. Why? See, because if I draw 2p, so 2p is like this. So when you move, and this is the nucleus. In between these two lobes, we have the nucleus. So when you move away from the nucleus, now when you move away from the nucleus, you will get the electron, right? Or there is the probability of finding the electron. So basically at nucleus it is going to be 0. S, it is maximum at nucleus, but P, it is 0 at the nucleus. So this is also true. So number of correct statements, they are going to be A, D and E. So 3 total, A, D and E. Okay, now let's do next question. Question says, which one of the following about an electron occupying the 1s orbital in an hydrogen atom is incorrect? Incorrect बताना है. So question says the probability density of finding the electron is maximum at the nucleus. That is for 1s. That is for 1s. अच्छा यहाँ पे क्या है कि basically अच्छा let's do another question. So question says the electron can be found at a distance 2a naught from the nucleus. देखो ये होगा, देखो this is true, this is true. क्यों? देखो अगर if I say कि 1s के लिए if I'm going to draw a plot for the probability density, this is going to be what? This is going to be like this. ठीक है, this is going to be this. Suppose I'm saying कि this is a naught, so we can even find the electron at 2a naught ना, we can find it out. तो ये तो possible हो सकता है. This is R. अच्छा यहाँ पे क्या है, इसको you can also understand in that way. How you can understand in that way? Because in 1s we do not have any node, so radial node is equal to 0. So if we do not have any node, so we can find out the electron, right? So radial node is 0. Next, the magnitude of potential energy is double to that of kinetic energy. So see, we know that kinetic energy is equal to minus of total energy, and potential energy is 2 times of total energy. So we can say magnitude of potential energy is double. Yes, it is true. Now the fourth one, the total energy of the electron is maximum when it is at distance a naught from the nucleus. No, ऐसा नहीं हो सकता. A naught distance means radius of the first orbit of hydrogen atom. Radius of the first orbit of hydrogen atom. So नहीं होता. See, E1 का is minus 13.6 into Z square upon 1 square, which is minus 13.6 electron volt per atom. But if we talk about the infinite shell, so this is going to be minus 13.6 upon Z square upon infinite square. So 1 by infinite is equal to 0. So here infinite is 0. So can you see this? Minus to 0. Minus to 0. So it increases. It increases. So fourth statement is the false. So incorrect statement, that is going to be the option number 4. Let's do next question. So next question, the plots of radial distribution function for various orbitals of hydrogen atom against R are given below. So this is R, P, D, F versus R plot, right? So wave starts from origin. This is clear. Wave starts from origin. So question says correct plot for 3s. So what do we need to check? We need to check radial node, right? So radial node is what? N minus L minus 1, which is 3 minus 0 minus 1, 2. It means curve should cut x axis 2 times. So here देखो 1 time. No. ये नहीं cut होगा. It should be like this, right? It should be like this. So no node. If we see this 1 and 2, so here node 2. So that is going to be the correct plot for 3s. So option number D. ठीक है? Now let's do next question. Correct statement about probability density. Probability density means probability of finding the electron at a certain point. So लिखा है accepted infinite distance from nucleuses. So लिखा है it can be 0 for 1s orbital. So probability density it is 0 for 1s orbital. So see, radial node in 1s is 0, right? So it means it can never be 0 for 1s orbital. Never. So it means this is not true. It can be negative for 2p orbital. Probability density cannot be negative because we can always find electron. So never. It can be 0 for 3p orbital. So 3p orbital, radial nodes n minus L minus 1. So 3 minus 1 minus 1, 1. So yes, because we have one position where we cannot find electron. So yes, it is true. It can never be 0 for 2s orbital. So 2s orbital is n minus L minus 1, so 2 minus 0 minus 1, which is equal to 1. But nahi, it is going to be 0 for 2s orbital because we are going to find one norm. So answer is going to be the third one. Okay. Now let's start next question. The electrons are more likely to be found. कहाँ मिल रहा है electron? So A है, C है, right? So in this region we can find electron. Always we are going to find out electron over here. That's a radial wave function plot. So in the region A and C. Option A is the correct answer. Clear enough? Simple questions. Now let's do next. Psi square R, what again? Radial probability. So one node. One node. So one node means n minus L minus 1. Acha, one more thing. Curve does not start from origin. So this is for S. And for S, L ka value 0. Curve does not start from S. L ka value 0. So it means we can say radial node is equal to 1. So n minus 0 minus 1 is equal to 1. So n value is 1 plus 1, which is equal to 2. So that is true for 2s orbital, right? 2s orbital. Now, which of the following combination of statement is true regarding the interpretation of the atomic orbitals? So let's start. Question says an electron in the orbital of higher angular momentum stays away from the nucleus than an electron in the orbit of lower angular momentum. Is it true? Let's say देखो orbital है तो we can say orbit का भी same ही होगा ना, because in the orbital, if I say orbit है तो in the orbit we have orbital, so in higher orbit we have higher orbital, तो orbit say you can relate. So nh over 2 pi and here nh over 2 pi. So here we can say 1h over 2 pi and here we can say 2h over 2 pi. So here 0.5 h by pi and here 1 h by pi. So it means higher orbital is going to have higher angular momentum. Right. The question says an electron in an orbital of higher angular momentum stays away from the nucleus. True. Very true. So first statement is true. Now second statement, for the given value of principal quantum number, the size of the orbit is inversely proportional to azimuthal quantum number. Azimuthal quantum number does not relate with size. Value of n relate with size. Right? Azimuthal quantum number is related to the subshell. So this is false. Next, according to wave mechanics, the ground state angular momentum is equal to h over pi. So beta h by 2 pi. So ground state is n is equal to 1 and here angular momentum is 0.5 h pi, or we can say h over 2 pi. So this is true. Now fourth, the plot of psi versus r for various azimuthal quantum number. For various azimuthal quantum number जैसे L is equal to 0, L is equal to 1, L is equal to 2, shows peak shifting towards higher R value. Peak shift हो रहा है, peak is going to shift. ऐसा नहीं है, it's not true ना, ऐसा नहीं हो रहा. Higher L के बाद peak shift नहीं हो रहा. This is not true. जैसे for 1s, if I draw for 1s, so it is going to be like this. If I draw for 2s, so this is going to be like this. कम हो रहा है ना peak. If I draw for 3s, so this is going to be like this. Okay, so no. So that is also false. So answer is option number 1. Okay. So now let's do last type of questions, that is based on miscellaneous things. So here we can have some questions on cathode rays and all. So let's discuss these questions, right? So let's start. So question says electrons in a cathode ray tube have been emitted with the velocity of this. Velocity is 1000 meter per second. So the number of following statements which are true about the emitted radiations. The first statement is de Broglie wavelength of the electron emitted is. So de Broglie wavelength h over mb. We are going to use this one. H ka value it is given 6 into 10 to the power minus 34. M ka value it is given 9 into 10 to the power minus 31. Velocity it is given, velocity it is equal to 1000 10 to the power 3. So on solving this we get 0.66666 kuch hoga into 10 to the power minus 6, which we can write as 666.6 into 10 to the power minus 9. So 666.6 nanometer. So this means this is true. Okay. Now next, the characteristics of electron emitted depend on the material. Nahi, cathode ray में the properties of the cathode rays, they are independent on the nature of the electrode or on the nature of the gas. So this is false. Cathode ray starts from cathode and moves towards or not true. Very true. Cathode rays are negatively charged rays and they are made up of electrons. So they start from cathode but they move towards it. Next, the nature of emitted electron depends on the nature of gas present in cathode ray tube. Nahi, nahi. That is true for anode rays. So that is false. So option A and C are correct. And if option A and C are correct, the total number of correct statements there they are going to be 2. Okay. Now let's discuss this question. The question says, according to Bohr's model of hydrogen atom, the angular momentum of an electron in a given stationary state is quantized is yes, nh over 2 pi. So for first orbit, angular momentum is 1h over 2 pi. For second orbit, that is equal to 2h over 2 pi. For third orbit, it is going to be 3h over 2 pi. So it is quantized true. Next, the concept of electron in Bohr orbit violates the Heisenberg uncertainty principle. In the light of above statement, choose the most appropriate statement. So basically concept of electron in Bohr. So basically Bohr का orbit है orbit कि now the electrons are present in orbit. But in the Heisenberg uncertainty principle, it says कि we cannot find electron in the orbit. There is a chance to find out the electron in the orbit, and that space where we can find maximum electron, that space is the orbital. So after the Heisenberg uncertainty principle, Bohr's orbit is replaced with the orbital concept. So it means both statements are true, but they're not correct explanation to each other, right? So it means both statement 1 and 2 are correct. So option 2 is the correct answer, right? Now let's do the next question. And I guess this is the last question of this chapter, atomic structure. So let's do it. Amongst the following statement, that which was not proposed by Dalton was, chemical reactions involve reorganization. So here you should know the postulate of Dalton's atomic theory, है ना? So please read it from your NCERT. That's it. Dalton's atomic theory, read it from your NCERT, read it from your notes. You will get the idea. This is memory based question. Involves reorganization of atoms. These are neither created nor destroyed in a chemical reaction. ये तो सही बात है, यही बोला था उसने. Next, all the atoms of a given element have identical properties included atom. बिल्कुल सही. Atoms of different elements differ in mass. True, true, very true. Next, when gases combine or reproduce in a chemical reaction, they do so in a simple ratio by volume. No, gases से नहीं. Dalton's atomic theory said that when two or more elements combine to form compounds, so elements are going to be present in simple ratio by mass. Volume का nothing. So this is the false. Matter consists of indivisible atom, yes, which can neither be created nor destroyed in a chemical reaction. That was by Dalton. So that is true. So option 3 is the correct answer. Okay. So students, we have discussed enough number of questions. It will give you enough clarity. It's just you have to solve other PYQs, and that's it. In the next video, I'm going to discuss the liquid state or solutions question. Okay, so please revise before before start with the liquid solution video. Okay, bye. Also, if you like this video, please drop a comment, right? And you can also join the PracBee Revision Program. And in the PracBee Revision Program, we are discussing all the topics in detail and we are going to cover all topics, right? So everything which is related to the PracBee Revision Program, that is in the description box. You can find all the details over there. You can write in the comment section if you need any kind of help. We will provide you whatever is required, right? So that's it. See you in the next class, and for the next class please study liquid solutions. So when you study liquid solution for the next week, we can do much better. Okay, so keep going, keep revising the things, just do it. Okay, bye, take care.